So we will start with setting up the playground, and I have shared a PDF document in the Slack channel. Maybe if you click on that link, it will give you all the instructions like what we should be doing to set up the playground. So the first thing is like you will have to start by clicking this link, and it will let you download the VM, which we will be using throughout the workshop. And these are the steps that you should be following to install everything. You'll have to follow the instructions as is. Please don't miss any steps. They're like very clear instructions. Like you have to be very careful, especially with the network settings, because the VMs needs network access or internet access to download the Docker images on the go when we spin up some Kubernetes clusters or some containers. And it also needs a local network connection in order to SSH the host. So please follow the steps as is. I'll also do it on my screen. I'll also have a recording. I'll be sharing it on my screen. If you have any issues, everything, you can always message me on the Slack channel or in the Q&A channel. I'll be shortly sharing my screen, setting up the machine. If you feel that the pace is a bit fast or is a bit slow, always feel free to tell me and I will adjust the pace accordingly. So these are the steps that you should be following while doing the setup. After you download the virtual machine from the link, just follow these steps as is. Import the VM that we have downloaded. Choose that virtual machine. Click on continue. And here we will set up these. Always ensure you give some better RAM. I'm giving somewhere close to like 6 gigs, but it's always good to give anything above 4 should be fine. Then just modify this MAC address policy setting. It all looks good. Then just click on import. And once if you click on import, it may take anywhere close to a minute or 2 minutes. Click on import. The VM has been imported. And now the first thing we'll be doing is like doing some network settings, which is very important. So we click on network and ensure just as per the documentation, make sure like the first one is host only adapter. And the next one is NATing. So this is very important, guys. So first adapter is like host only and the next adapter is NAT. Just make the settings as it is shown on the screen, and we won't be touching anything else. Just click OK. Then we are all set. Just click on start. So the username to log in is the username Vasant, and the password is Ubuntu. Everything is provided in the document, in the setup document. And then switch user as root, and the password is Ubuntu. Only this particular screen for the next 1 minute looks small, and then going forward, it will be like pretty big. So, and then issue the command bh client, and then try to grab the IP address of this machine, because we will be using a terminal to SSH into the box and continue with the rest of the workshop. So here the IP address for this machine is 192.168.56.104 for my machine. Similarly, you should have an IP address. So grab the IP address and then just test it from your shell or terminal or whatever you use. Just SSH, the username is Vasant at the IP address. Yes, and the password is Ubuntu. So switch user, password is Ubuntu. Cool. And then there is one document that you all should be testing it. It is like the number step 4 in the documentation, /requirements. And once it is done, you should be able to see the screen. If you could see the screen, we are all good to go ahead with the rest of the workshop. Can you all just raise your hands? Are you able to follow till this step, or do you want me to wait for a while, or do you need any assistance? Just leave a message in the Slack or somewhere.
Yeah, so we just got a message saying that someone needs a minute.
Yep, I have answered it.
Ah, cool.
Look, no rush, guys. We will just wait for a couple of minutes to ensure everyone is on the same page. We are on time. So, yeah, no rush. And now we will be setting up the infrastructure for the workshop. So I'm pretty sure once if you give the command /requirements, and it should say everything is available. And the next, probably the first thing I'll be doing is I will be sharing with you all a documentation which we will be following for the rest of the workshop. It is like a huge documentation, somewhere close to 200 pages. So could you all please check the Slack channel? I'll be sharing it over the Slack channel. So I have just shared a document on the Slack channel which says like attacking, defending, and monitoring your Kubernetes ecosystem. We will be following this documentation and we will be following the steps as is throughout the workshop. It will cover all the modules like attacking, defending, monitoring, and runtime protection. Could you all please check the Slack channel and download this documentation? Even if you happen to miss any steps during the workshop, this is your go-to place. Anything and everything that we do during the workshop will exist in this documentation. So the next step that we will be doing is like everyone has to issue the command as is, as you see on my screen, create -n workshop -w2. This will set up the rest of the playground for us. It will bring up the whole environment, different Kubernetes clusters, and all the required containers for the workshop. So I am sharing my screen and I'll show you how to do it. And depending on your internet connection, this step might take a little longer. Some machines may take like 5 minutes, or some people might even take 10 minutes, but don't rush. While this is happening, I'll be covering some theory. So don't stress yourself at this stage, but this is very important stage. If anybody has any difficulty or any errors during this stage, just reissue the same command again. The command is create-n workshop-w2. If you have any difficulty during the workshop, please just copy and paste the commands through the workshop. At times, you may have to change the IP addresses and the port numbers here and there. You should see something like this. Is this happening? Are we good to go with the theory while this is happening in the background? Because like I mentioned, this step may take anywhere close to 5 to 10 minutes. So I will start with some theory. So once it is done, it will give you something like this. And make sure you copy this, all IP addresses and port numbers into a text pad. If not, just leave this screen as is and open a new terminal. At least open 2 or 3 terminals from which we will be doing the stuff. So while this is happening, I will cover some theory part.
So Vasant, there's someone mentioning an error on the start code base server.
Right, like I mentioned, just make sure you have like proper internet connection. So just give some command like ping-c3 some google.com and make sure you have proper internet connection, and then give the command create-n workshop and it should work. If you have any issues, please rerun the same command again. Because I have been using the same VM for all the workshops, it's working absolutely fine. If it is not working in your machine, there is something wrong with your internet connection. Christian, can you still see my screen?
Yes.
All right, it says containers and Dockers, right?
Yeah, containers and Docker, yeah, on a diagram.
Perfect, cool. So let the setup do it work in the background and let's complete some theory part. So let's start with the very basics of microservices, Docker, and then the Kubernetes. So the microservices architecture splits your application into multiple services that perform fine-grained functions and are still part of your application as a whole. The advantages associated with microservices, such as like their allowance for agile development and artifacts, and then architecture that is highly maintainable and testable, which will enable businesses to develop and roll out new digital offerings faster and also evolve its technology stack, makes it the obvious choice. So where do you put your microservices? In containers. So containers are the packages of your software that include everything that it needs to run, including the code, the dependencies, libraries, binaries, and more. This gives developers the ability to create predictable environments that can be run anywhere and allows container-based applications to be deployed easily and consistently, regardless of whether the target environment is a private data center or the public cloud or even a developer's personal laptop. So this containerization is this trend that's taking over the world to allow people to run all kinds of different applications in a variety of different environments. And when they do that, they need an orchestration solution in order to keep track of all those containers and schedule them and orchestrate them. That's where Kubernetes comes into the action. Kubernetes is an open source orchestration platform that automates many of the manual processes involved in deploying and managing and scaling the containerized applications. You can think of Kubernetes as you would a conductor of an orchestra. In the same way, a conductor would say how many trumpets are needed, which one plays the first trumpet, and how loud each should play, A container orchestrator would say how many web server front-end containers are needed, what they serve, and how many resources are to be dedicated to each one. And Kubernetes does not include functionality for creating or managing container images, and it does not by itself run containers. It needs to work with an external container source and runtime. As Kubernetes is a container orchestration, it needs a container runtime in order to orchestrate. Well, Kubernetes is most commonly used with Docker, but it can also be used with any other container runtime like runc, CRIO, and containerd, and other container runtimes that you can deploy with Kubernetes. And Kubernetes is hot in the DevOps space and is now the most wanted platform among developers. Well, getting started with Kubernetes is easy. It takes like a matter of minutes to set up a new cluster and run applications. However, the real concern or the challenge is what follows this, the pivotal question of how to make sure your cluster is secure. For any organization, security should be like the primary concern and not an afterthought, because we all know well, like especially in the current COVID environment, prevention is always like better than cure. In fact, let me tell you what happens in the real world when the Kubernetes clusters aren't secured properly. On July 19, 2019, like the second largest auto finance company in the United States, who operates like a responsible disclosure program where security researchers can disclose potential vulnerabilities, received an email. The email was not a vulnerability disclosure email, but an email notifying them that they have been hacked. And the company was asked to pay like 80 million civil penalty for its role in the cybersecurity breach. And it is like capital one. And there is another one, like with the values of cryptocurrency skyrocketing and the limitless compute resources located in the cloud, hijacking resources has become a lot more lucrative than stealing info. And world's famous automaker was one of the earlier victims of cryptojacking when a Kubernetes cluster was compromised due to an administrative console not being password protected. It's Tesla. These are like few examples. And what was interesting about this attack was the number of ingenuine precautionary measures taken to avoid detection. In this attack, the attackers made sure like the mining script didn't use enough CPU resources to cause an alarm or to get detected. And they also used a non-standard port, making detection based on port traffic virtually impossible. And we'll be looking at it in today's workshop as well. So these are just two examples of many incidents, but there are many other incidents like this. Well, now that we have understood the dangers facing our industry and given the knowledge gap among teams and the lack of solid security measures to protect Kubernetes, you might be wondering how in the world are we going to secure all these moving pieces and stop these attacks? And that's exactly what we are going to learn today. Cool. Anyone, any issues with the setup, or is it all like going fine? So is everything fine? Can you all see the screen where it says this one? And make sure you copy this output into a text pad or some document, or just leave the screen as is, because we'll be using these URLs going forward. So what I want you all to do is just copy this IP address, put it in your browser, and I have already provided the username and the password in the document. However, the username is admin, the password is Vasant. You should be able to log in. And this IP address will change for each and every one. You will have your own IP address in your local works. So just click on the infra, and you will have something happening like this, which will be setting up our infrastructure. And once if you reach to a stage where it says proceed and abort, just leave this one as is. Don't neither click on proceed nor abort at this stage. I'll tell you when we have to click the next coming. So Are you all good till here? Can you all see the screen? So if you are till here, you're like pretty good to go ahead with the rest of the workshop. Can you queue? Somebody sent me a message saying that stuck on installing build server. Like I mentioned, that step will take some time because it will pull down like so many Docker images and containers, and it needs to have some good internet connection. But don't worry, let it happen in the background. But still, we can go ahead with the rest of the workshop. Can you all raise your hand or give some thumbs up to go ahead with the rest of the workshop? All good. So some people are still, setup is happening in their machines. However, I would like to cover the very basics and very high level commands of Docker just to ensure we are all on the same page. And then we will see some very high level commands of the Kubernetes as well. So if you open the documentation, there is a section that says like common Docker commands. So I'll be showing the same stuff one more time. But if you have any difficulty typing them, you can just copy and paste them in your screen. Right, so the first command that I'll be using is like to find out the Docker version in my machine. It's docker -version. And for example, if you ever want to pull some image, we use the command called docker pull and the name of the image. For example, in this scenario, I want to pull something called HTTPD, or maybe if I want to pull something called Alpine. So this is how we use the command docker pull and the name of the image that we would like to pull. Or for example, if you want to search for any image, we use the command called docker search and the name of the image. For example, if I want to search HTTPD, we use the command called docker search and the name of the image. And for example, if you want to run any container, we use the command called docker run, and we provide a name for that container, for example, HTTPD. And we will be providing like some port numbers, and then we provide the image. So this is how we are running an HTTPD image, which is like a web server. I'm just canceling it. And if you want to see like all the images that are running inside your machine, the command which you use is like docker ps. And if you want to see all the containers that ran and that are shut down, we use the command, or we pass the flag -a. So this is the one which we ran a few minutes ago. And for example, if I want to remove that one, we pass the command docker container rm, and that's how we delete a container. And in the PDF, I have also given some additional commands, like for example, if you want to exit into one of the containers, how you do it, or if you want to stop a container or how to kill a container, everything is provided in documentation. So just keep or just practice and try those commands after the workshop. And another command that we would like to show you is if you want to see all the images that are running inside the machine, we provide like the Docker images. It will list all the images that exist inside that machine. And another important command is like, if you want to see the logs of any container, we pass the command called docker logs, and we provide like the name of the container. It will provide logs of all the containers. You can try with any of the containers that are running in your machine. And there is a section called Docker Kung Fu, which are like some good useful commands which we'll be using in the real time. For example, if you want to run or get the names of the containers that are running, we use the Docker PS and we are formatting it using Go templates. And if you want it in the table format, so container ID and the name of the container. Cool. So that pretty much covers like the very basics of Docker. I don't want to dive deep inside the Docker stuff. We will be covering the content. We will be covering most of the stuff in the Kubernetes, and we will do some basic commands of the Kubernetes as well. Right. Well, there might be some Kubernetes experts here. This content may sound a bit redundant to you, but I want to make sure we are all on the same page. So I want to start by explaining some important relevant components of Kubernetes, which we will be attacking in today's workshop. So like you see on the screen, these are like the various important parts of the Kubernetes. Well, Kubernetes follows a client-server architecture model, and the working Kubernetes deployment is called a cluster. You can visualize a Kubernetes cluster as two parts, the control plane and the compute machine or the nodes. It is possible to have a multi-master setup, but by default, there is a single master server which acts as a controlling node, and it is like the point of contact. I'll explain you what that means. So what happens in the Kubernetes control plane? So control plane, if the control plane is the brains of the operation, the worker nodes are the muscles. So let's begin in the control plane in the nerve center of the Kubernetes cluster. So the control plane here, we find the Kubernetes components that control the cluster along with the data about the cluster state and the configuration. These core Kubernetes components handle the important work of making sure your containers are running in sufficient numbers and with the necessary resources. The control plane is in constant contact with your nodes. If you have configured your cluster to run in a certain way, the control plane makes sure it does. And the next important component is Kubernetes API server, Kube API server. So if you need to interact with your Kubernetes cluster, talk to the API. The Kubernetes API is the front end of the Kubernetes control plane handling internal and external requests. The API server determines if a request is valid, and if it is, processes it. You can access the API through the REST calls or through the Cube Ctl command line interface or through other command line tools such as like kubeadm and many other tools. And what is Cube Scheduler does? Is your cluster healthy? If new containers are needed, where will they fit? These are the common concerns of the Kubernetes scheduler. And the Kube Controller Manager. The controller takes care of actually running the cluster. And the Kubernetes Controller Manager contains several controller functions in one. One controller consults the scheduler and makes sure the correct number of pods are running. And if a pod goes down, another controller notices and responds. So another important component is Xcd. So configuration data and information about the state of the cluster lives in Xcd. It's a key value stored database. It's fault tolerant and distributed, and Xcd is designed to be like the ultimate source of truth about the Kubernetes cluster. Now let's see what happens in the Kubernetes node, the worker nodes. The worker nodes are the muscles. They run and control all the pods and containers from your cluster. You can have 0 or more worker nodes on your cluster, although it is not recommended to run your pods on the same node as the control plane. The main components of a workers are the Cubelet, the container runtime interface, and the Cube Proxy. As shown in the image, let's discuss what the pods are. A pod is the smallest and the simplest unit in the Kubernetes object model. It represents a single instance of an application. Each pod is made up of container or a series of tightly coupled containers along with options that govern how the containers are run. And next important piece is Cubelet. Each compute node, each worker node contains a Cubelet. It's a tiny application that communicates with the control plane. The Cubelet makes sure the containers are running in the pod. When the control plane needs something to happen in a node, the Cubelet executes the action. And the last one is the Cube Proxy. Each compute node also contains a Cube Proxy. It's a network proxy for facilitating Kubernetes networking services. The Cube Proxy handles the network communications inside or outside of your cluster, relying either on your operating system's packet filtering layer or forwarding the traffic itself. So we will also look into one quick stuff now. Let us visualize how an attacker will look at like different components of the Kubernetes architecture. So when an attacker has to target a master, like in the previous diagram we have shown, like the diagram shows all the communications go through like the Kubernetes API server. This is what defines and controls all of the Kubernetes management and operational functions. It is generally exposed on every deployment since it is needed for management purposes. You know what? But exposing your API server to the public is the most common entry point for attackers. It is actually a really juicy target. Malicious attackers or actors will always try to get access to the Kubernetes API server and the control plane. And once it is compromised, they can then proceed to compromising the whole cluster. At times, it may not be a bad day for just your cluster, but also your underlying cloud account or the underlying infrastructure where the cluster is running. And the next important component that will be attacked is like Xcd. It's a key value store and a core component of the Kubernetes cluster. And it's the main data storage of your location of your cluster. This means that all of your cluster objects are saved here. Xcd is considered like the source of truth for Kubernetes. It is used to store highly sensitive configuration data, but it is also easily left unprotected. Anyone who gains access to Xcd targets to retrieve service account tokens and secrets. And once if an attacker has access to privileged secret or a token, then it's game over. A very quick win for the attacker. We'll be looking into that stuff during the workshop. And likewise, pretty much the attackers will be targeting the Cubelet, like we have seen on the node, like Cubelet exposes to endpoints, read-write endpoint and read-only endpoint. And we'll be looking into attacking that stuff. And the next important thing is like container runtime. This component enables the functionality required to start, run, and manage containers on a given node. I can't stress enough how important it is to secure your workloads to the containers. A privileged container, when gained access, gives an attacker the privilege to run a command in the context of the container and the option to escape and access the host resources. This is an endgame too. An attacker who gains access to the container has gained access to your cluster and eventually the underlying account. In today's workshop, we'll be looking into all the stuff like the initial access, like gaining access to the Kubernetes cluster by using like anonymous access or an insecure port or Cubelet read-write ports or read-only ports. And we'll be looking into abusing a web application and gaining access to the underlying Kubernetes cluster via a pod. And we'll be looking into like executing into multiple different containers or doing some remote code execution inside the stuff. And we will also do some persistent techniques such as like backdoor containers or malicious administration controllers. And we will be doing some privilege escalation techniques, and we'll be looking into defense evasion techniques and credential access. And we'll be performing some lateral movements and collection. And then we'll be covering most of the stuff in today's workshop. So now let's quickly start with some very basics of the Kubernetes commands. So once I want you to all to start by just running this command, and it will ensure like it will give you the information. It will say that your cluster is up and running. If it is up and running, it will give you the information about like your control plane, the IP address and the port number, and also like the kube DNS. Are you all still here? Do you have any issues with the pace? Am I going too fast or too slow? Just raise your hand if it is everything is fine and we are good to go ahead with the rest of the workshop. And we are pretty good with the timing. We are on pace. So once this section is done, we will have a quick 5 minutes break. Every 1 hour, I will give you like a quick 5 minutes break to revive, and then we'll be continuing with the rest of the stuff. Just raise your hand. Are we good to go? Perfect. Good to go. Cool. The documentation, you have all these commands, guys. So in order to identify like your Kubernetes cluster info, that is the command we use. It's pretty much the same in the for Docker. We used the command called Docker client, Docker, and then we pass the verb like command run, get something. Pretty much we'll be using the same thing for Kubernetes. We'll be passing like the Cube Ctl client, and everything by default is installed on your machines on this workstation. You don't need to do anything. I have set it up everything for you. So we use like the Cube Ctl and we pass the verb get to get some information, and then we pass the resource name. It could be like the pods or the nodes or the namespaces whatsoever. For example, if I want to get the information of the pod, kubectl get pod is the command. If I want to see all the pods, I will pass the flag -A. It will give me all the pods that are running inside the cluster. At this stage, you may not see all these containers, but don't stress. You will be looking these many containers going forward. So likewise, instead of pod, I can give something like node, which will give me like the information of the nodes that are running inside the cluster, which means I have one control plane, the master node, and I have like 2 worker nodes for the workshop. Pretty much you can get any information, like for example, deployments. So use the command called kubectl get. And one last one, if you want to see the namespaces, we pass the flag get namespace -A. It will list all the namespaces inside the cluster. And for example, if you want to exclusively get the resources in particular namespace, we pass the flag called -n in the namespace. For example, this command says, hey, please get all the pods that are running in the namespace called kube system. So we pass the flag -n and kube system. This way I will be getting all the pods, or I am filtering the pods that are running in the kube system namespace. And another important command is like, if you want to see the configuration of any of the file, we pass the flag called -o YAML or -o JSON. For example, Cube Ctl get pod. In the kube system namespace, I'm giving this one. In the format, I want the output in the YAML format, so I'm passing the flag -o YAML. It will give me like the configuration of that pod in this YAML format. So we'll be looking into this stuff going forward, but that is the command that we use. If you want the manifestation file in the JSON format, we pass the flag -o JSON. It will give everything in the JSON format. We'll be using these commands in the workshop. And for example, creating anything, we pass or we use the verb called kubectl create. For example, in this scenario, I want to create called namespace Barcelona. It says namespace created. Kubectl get namespace. Cool, the namespace Barcelona has been created 6 seconds ago. So that's how we create something. And for example, if you want to create some deployment, we use the command called kubectl in the namespace called besides, or maybe I will use the Barcelona, which I have created. Deployment comes next. It says deployment created. We will see the deployment using the command kubectl get deploy -n Barcelona. It says it is coming up. So that way we create the deployments. And we can also scale the deployments, and we scale in like scale out by passing the command called -replicas. You have that command in the PDF document. You can just try it. And for example, if you want to edit any of the deployments, we use the command called kubectl -n Barcelona edit deployment. For example, this one, it will give you an option to edit. For example, if you want to change the name of the image, or if you want to change some specs or the flags, or if you want to change anything else, you can change here. And another important command is like kubectl auth cani. This will tell you what kind of privileges you have inside the cluster. For example, kubectl auth cani, and then I pass the verb called get. The resource name secrets, we are asking whether do I have the privileges to get the secrets or not. It says, yes, I have privileges to get the secrets. Likewise, pods, yes. So this is how you check for the privileges, kubectl auth cani. Or if you want to see the complete list of privileges that you have got, use the command called kubectl auth cani -list. So this way here it says you have like star on the non-resource URLs and the verb star, which means you can perform almost everything because you're an admin on this cluster at this stage. And the next command is like we'll be looking into some secrets. Cube Ctl get ns. And for example, if you want to get secrets in the namespace called cube system, Cube Ctl get secret -n cube system. It will list all the secrets that are running or that exist in that namespace. And if you want to describe or if you want to get the token of any particular secret, we use the command called Cube Ctl describe secret, and any random one, for example, name of the token, and then we pass -n the namespace. It will help us to describe the secret, which will eventually give us the token. And using this token, you can pass it to the REST API to authenticate, and then for authentication and authorization, and you can start interacting with the cluster. So you'll also see how attackers will abuse these things. And at times during the deployment or something, we may have some issues. So in that scenario, if you want to identify what's going wrong with any deployment or any daemon set or any pod, use the command called describe Cube Ctl describe. For example, I want to describe this pod, something called, and I will provide the name. It is in the namespace called monitoring. So that way it will describe, in case of any issues, it will tell you what's going on, what's going wrong with this particular pod or the deployment. That way, this particular command will help us to troubleshoot any stuff. Cube Ctl describe. And needless to say, another important command is like Cube Ctl logs, which will give us the logs of any particular pod, Cube Ctl. So that is the command that we use. Cube Ctl logs in the name of the particular pod. It will give us all the logs of the container. And another important command is like Cube Ctl get events, which will help us identify all the events that are happening inside the cluster. It says unhealthy, something is unhealthy. So let us see what's unhealthy. Cube Ctl get PO. Here, it says pod, Falco exporter. It says something is healthy, but it is up and running. Readiness probe failed, some issues. So that way you identify the events that are happening inside the cluster. And I have like few other commands listed in the documentation, guys, if you want to exit into one of the running containers, how to do it. And another important piece that I would like you to know is like the Cube Ctl config. So every time you issue a command using Cube Ctl and the way it is interacting with the Kubernetes cluster, there is something happening in the background. So in order to understand what that is, it says you're interacting, your current context is the current context, and there is something defined in this current context, and we will see what that is. Cube Ctl config view. It will give you the information of your config file. So here it says, this is the cluster that you're interacting with, and this is the user that you're interacting with, and this is the name, and this is where it has like the client certificate and client key data. So every time you want to interact with a Kubernetes cluster, the Cube Ctl client will ensure there is a kube config exists, and it has like the defined certificates to ensure it has proper authentication and authorization in place. Pretty much. And there are like so many other important commands for you to try. Just test them and play with them. And if you want to identify what are like the total resources that exist inside the Kubernetes, we use the command called Cube Ctl API and resources. So these are the different types of resources that exist inside a cluster. Cube Ctl API and resources. It says like the bindings, the config maps, endpoints, events, limit ranges, namespaces, nodes, pods, secrets, service account services. These are the different types of resources that exist inside the Kubernetes cluster. And these are like the short forms. Instead of getting something like namespace, instead of typing the full word namespace, we can just type NS. And if you want to get something of good appropriate output, we use the command called Cube Ctl API resources -o wide. It will give a proper and more information like what verbs applicable to that particular resource. -o wide is always useful in some other scenarios as well. For example, if I want to get Cube Ctl get nodes -o wide, it will tell us like the name of the node, the status of the node, the version and the IP address, and where it is deployed, on which where it is actually running. It will give all this information. So it's always good to use the command -o wide. Cool. That pretty much covers all the basic stuff, guys. We are almost close to like 1 hour. We have set up the workstation. We have seen like the basics of Docker and the Kubernetes. And the next 1 hour, we will be completely working on like the attacking stuff. And then we'll be looking into like the defending. And then we will have different kinds of monitoring, and then runtime monitoring and container scanning, all these kinds of stuff. So we will take a break for 5 minutes and we will catch up in the next 5 minutes again. Is everything good? Anybody, any questions? Feel free to share them on the Slack channel or leave a message here. And if you feel that you're missing something, anything and everything that we did so far and whatever we will be doing for the rest of the 3 hours, everything is mentioned in the documentation. If you have missed the documentation, it is available in the Slack channel. Please download it from there. Cool. I'll catch up in the next 5 minutes. Thanks. All right, guys, I'm back. So let's start with our attacking and defending modules. So we have like close to 13 scenarios in this one. So we have like scenario 1, 2, 3, and 4. So you also have the solutions for the scenarios. You can just try them. If you feel that I'm going slow or going fast, you can just try it yourself. You also have the solution. So let us start with scenario 1, 2, 3, and 4 first, and then we'll go ahead with the rest of the ones. The first 3, 4 scenarios are pretty straightforward. So we will see what that means. So in the scenario 1, we'll be looking at the stuff called anonymous access. So this anonymous access is not enabled by default. However, sometimes some engineers like me, in order to do some research or to make their lives easier, they can create an anonymous user or give some anonymous privileges, and they eventually forget closing that stuff. So if there is an anonymous access enabled in any cluster, we will see how to identify it and what we can do in that scenario. So like the first thing to realize when thinking about securing cloud Kubernetes-based clusters is that there are attackers and bots constantly searching the internet for exposed API servers and host of ports that are related to Kubernetes. It is critical that the Kube API server is not left publicly exposed. Although the default setting is secure, but exposed API servers are still the main entry point for attackers to compromise a Kubernetes cluster. So we will see here. So the first thing I want you to try is issue the command called Cube Ctl Cluster-info, the command which we have seen before. It will give you some information about your cluster. And the next command that I want you to try is like Cube Ctl get po-wide, and just make a note of some important containers. For example, these are the 3 we have, like work, control plane. So let us Cube Ctl get po-wide -n cube -system. So I want you all to identify the control plane. Just make a note of this IP address 172.180.5. That is the IP address of your control plane. So in order to go ahead with the rest of the workshop, I want you all to quickly install Nmap. So just copy and paste the commands that I have given in the PDF. Cool. Nmap is already installed. We will quickly scan. So this is the IP address of the control plane. And if you Google or just do a bit of research, like what are the important Kubernetes ports, it will give you the list of ports. So to make your lives easier, I have already given those ports for you. We just run the nmap command on these ports for now. So you will see an output something like discovered open port on 4663, 2380, 10250. We will be trying and playing with all those ports. So it says like 2379 Xcd Client, 2380 Xcd Server, and 4663, 6443, 10250, 10255. We'll be exploiting all those ports. So usually the Kubernetes secure port runs on either port 443 or port 8443 or port 6443. Here I'm giving you like the direct solution. However, after enumerating a bit and playing with it, you will get to know, okay, this is the Kubernetes and this is the port that is running. So what I would do is like, I will do curl to that particular port on that IP address, 172.180.5 on port 6443. And I also have JQ installed on your machine to get a good output. There you go. So you are able to interact with the Kubernetes cluster on the port 6443. This is the IP address of the control plane, and this is the port where the API is accessible. And because there is anonymous access enabled, which is letting you to access with different APIs on this port number. And what we do is like, I further go and explore other stuff, such as like /API will give me like the server address and the information, the server address, the stuff, API or /v1, which will give me different endpoints that are available on v1, like service accounts or pods or services, secrets, etc. If I want to further explore API v1, for example, I would start with the pods. Can you all still see my screen? Just hands up. Cool, perfect. So, and if you want to see some other stuff, we will use something like secrets. So that way you can use this anonymous port. Just one sec. Likewise, for example, if you want to gather the information of the nodes, you will pass the flag called nodes. That way it will give you all the information. So when you have like an anonymous port or anonymous access enabled on the Kubernetes cluster, it's almost like game over. An attacker who has anonymous access to the cluster, he can do anything and everything. And we will also see the reason why, this anonymous access is enabled. So we have, probably I'll show it to you after a few sessions when we discuss about the roles, the role bindings inside the Kubernetes cluster, why or which role has actually enabled this anonymous access, and I'll also show you how to fix it. So we have seen the Kubernetes anonymous access on a secure port. Now we'll be moving on to like the scenario number 2. So from the previous Nmap results, so we came across this port. We have identified this is like a secure port with anonymous access. Now let's try to play with port 4663 and see what we have there. So what I would be doing is like, and because this is an insecure port, what I would do is curl HTTP 0.5, and I'll pass the port number 4663, and the port number may vary for different clusters. This is, for this scenario, I made your lives easier, but any attacker who gains like initial access or who has like Nmap access, they would probe and enumerate the stuff. That's what we are doing here. So I'm trying to, oh, looks like there is something I could still access the same stuff, but this is like insecure port. The major difference between secure port and insecure port is like on the secure port, until unless there is an anonymous access, the users or the attackers won't be able to play or interact with the API. Whereas if the insecure port is enabled, they don't need authentication. They can straight away access and start playing with the cluster. So let us see what else we can do when an insecure port is there. So what I would do is, for 663/API. There you go, the same stuff. API/v1/pods. Likewise, you can get the secrets, everything. Even this insecure port is not enabled by default. Like I said, there is always a possibility that somebody could enable and leave it by default. So it's always good to ensure, or you check that during your risk assessments or during your penetration testing. So this covers. Yep.
Just going to interrupt for a bit. People are saying that they cannot, some of them cannot see your screen.
Can you see my screen?
I do see your screen, but there are at least 3 people that say that they cannot see it. So if you can try to stop sharing and share again to see if that fixes the issue.
Can you all see my screen now? Christian, can you see the screen?
Yes, I can see it. And let's see if people can confirm. Can you confirm on Slack or raise your hand if you can see the screen again?
Yeah, that's strange. Chris, you can see it, right? And others can't see it.
Yeah, I can see your screen. Yeah, they say like they see Slack now, which yeah, I'm seeing your Slack screen. Now, yep, I'm seeing the terminal.
Yeah, it's all good. I don't know why some people can't see it. Okay, they say visible now, good now, cool. No worries, guys. I'll quickly cover like the scenario number 2 again. So during the Nmap scan, we have identified some ports, and we have in the first scenario, we have seen like how to attack or access like a Kubernetes cluster when anonymous access is enabled using a secure port. And this scenario, we will be trying to access and see what happens when there is an insecure port or the Kubernetes cluster is accessible via some other port called insecure port. So what I will be doing, I'll be doing pretty much the same stuff, but I'll be accessing it via other port 4663 where the insecure is running. And just instead of the flag HTTPS, I'll be providing the flag HTTP. So, and you will be able to do the rest of the stuff pretty much like API v1 pods or nodes, etc. So the only difference between the anonymous access and insecure port is like, if there is no anonymous access enabled, you won't be able to interact with the Kubernetes cluster via secure port. Whereas with insecure port, you don't need any access or authorization at all. If there is insecure port left by default, the attacker can start playing with the cluster straight away. So I'll be moving on to like the next scenario, which is like abusing the Cubelet read-write port. So Kubernetes, if you just Google, it says like Kubernetes read-write port is available on 10250. So what I will be doing is this time, after running the nmap scan, I'll be pretty much doing the same stuff, but this time I'll try to probe port number 10250. Pods. There you go. Likewise, if you the other is like if you want to see the only running pods in the cluster, we shoot a flag like running pods. It will give you all the information of the pods that are running inside the cluster. So this is what you can do using a kubelet when a kubelet read-write port is accessible inside the network. So the major difference between kubelet read-write port and read-only port, as the name implies, using the read-write, you can read at the same time you can write, which means interact with the cluster. If there is, by default, if this kubelet read-write port is accessible, it's almost like game over. The attacker can spawn different containers, they can spawn some shells in that, and they can gain access to the underlying cluster. So there's a section called extra mile in the documentation. So for example, I want you to all to just try a few commands. This way you can get all the running pods inside the cluster. We'll give you the containers that are running. So what I would like you all to do is, there is a container called Xcd Client, and let's execute some commands using a kubelet read-write port. Xcd Client. So we're executing a command using the kubelet read-write port on the container called Xcd Client. There you go. The command has been executed on one of the containers that are running inside the cluster. And once, needless to say, like once if you know when you can actually run some commands on the containers, you know what to take it ahead. Like you can grab like the EC2 instance metadata, or you can even like grab a reverse shell and you can do heaps. So under the extra mile section in the documentation, you have what you can try and test. Just follow those commands and you can even get a reverse shell and gain access to the underlying cluster. And the next one we will see is like the kubelet. This time it's only read-only port. So the read-only port runs on port 10255. It's HTTP. Pods. So using the read-write port, you can always gather some information. So it's pretty much, and there are like other options, other things that you can always try, and everything is provided in the documentation. And you can also explore different endpoints that can be accessible on the kubelet read-write port and read-only port. Just Google a bit and you can always play with different things. Well, that covers the first 4 scenarios, and now the game will be up. We will be like chaining multiple attacks. From scenario 4, we will initially try to gain access to one of the pod or the container that is running using a vulnerable web application. And using that web application, we perform some remote code execution, and then we perform some lateral movements until we gain full complete access to the cluster and the underlying cloud account. So on your screens, you will have something like this. So if you go back, there is something called dev environment, and we also have called web application. Just copy and paste this URL inside your web applications. There you go. There is some kind of web application running, and let's issue some commands. Test ls. It looks like we are getting some output. Test id. However, that output seems to be a bit encoded. So we will see what is the output and how to decode it. For example, I'll copy this one. Echo 264 MD. So the output of this one, when we decode, it's like it says UID 0, 0. So when we pass the command called test-id, it says the container is running with the root privileges. So, and we also identified that there is some kind of command injection or remote code execution bug in this application. So what we are going to do is we try to perform some remote code execution and try to gain access to the underlying shell. So for that, what I'll be doing is you can either use your VM or you can also use your local host. For example, this is my local host. I'll try to identify the IP address of my local host. One 192.168.0.3. 192.168.56.1, and I just try to ping it and see whether the machines are communicable. Cool. All good. So like provided in the machine, what I'll be doing is like I'll be using a Python reverse shell to gain access to the container using like the vulnerable web application. So for that, what I'll be doing is I'll be running a netcat listener on my machine. So netcat -l 4444. And in the web application, what I'll be doing is so there is a command that's been provided to you in the documentation. Just copy and paste it and make sure you make some changes like the IP address and the port number. So the port number that I used is like port 4444. Just 1 second, guys. I'm just replacing the port number where I'm running the netcat, and also this is the IP address of the host where netcat is running. So I'll just click on encode. Something is happening here, and eventually it should get me a shell. There we go. We got the shell. And being an attacker, what I would do is like I will do some initial assessments, like checking for some environment variables and other stuff. So pretty much I do the same stuff. I'll check for environment variables, and after grabbing some things I identified, there is a Kubernetes something which reveals us that this is a pod, or this is a container, or this is a web application running on a container that is hosted on the Kubernetes. So from here, what I would do is like pretty much like an attacker, I will do some enumeration, try to gather some information such as like Kubernetes service, port, and other stuff. And with the basic stuff, with the basic knowledge that we have learned during the basic commands, in order to interact with the Kubernetes cluster, we need something called Cube Ctl or Cube Ctl Config. So what we do is we quickly download that one. So I'll go to cd/temp, and if you miss some commands, each and every command is available in the documentation. You can simply copy and paste it. There you go. Let's slash.
Hey, Vasant, there's someone that says that one of the commands is not correct in the documentation, that if you can send it, I'm not sure which one it is though. So David, if you can tell us like which one it was.
Is it in the Slack?
Yeah, it's saying on page 49.
Oh, sure. This one. Just one sec. Send the command. You just need to replace the IP address and the port number. And you don't need to use this one as is. There are like, if you search for something called reverse shell, there are like so many commands or so many reverse shell snippets that are available on the Google. This is just one example that I picked up. So you can use this one. So what I did is like, I have downloaded like the Cube Ctl. There you go. And now I'll quickly give the right permissions to this one. And I'm going to move this one to the bin folder. Perfect. So I will quickly check the same stuff that we have tried before. Cube Ctl get cluster-info. Successful. We are able to interact with the Kubernetes cluster using the pod that we gained access to. So from here, we try to do some privilege escalation, some lateral movements, and gain access all the way to Kubernetes cluster and the whole account. And we will be going to use some other command that we have learned before, Cube Ctl auth can I - list. It will tell the privileges that we have gained on the Kubernetes cluster. Pretty much these are the commands that we have for the pods, for the secrets, and for the service accounts. We can get, list, create these kinds of stuff. Now, Cube Ctl auth PO can I get pod? Yes. Cube Ctl auth can I get PO? Yes. Cube Ctl auth can I get secrets? Now it says you can get the information of the pods, but you cannot get the information of the secrets. Looks like there are pretty limited privileges for you. So let us see how we can bypass certain controls, and let us see how we can gain complete access to the cluster. At this stage, we have very limited access because we are not able to access the secrets across the cluster. Likewise, we may not be able to access many other stuff across the cluster. So what I will do is we will create a file called Cube Config. I have already created that for you. And guys, if anybody has any difficulty copying the commands, instead of copying them as is, just make sure you put them into a text pad, format them, and then paste them. Sometimes copying or pasting directly from PDF may not work. Right, cool. I have created something called config.sh. So we will see what this config.sh is. So it is basically trying to grab the config server IP address by issuing the commands called, this is like a basic script. For example, if I run this same command on my terminal, we'll get the IP address of the cluster. Likewise, it will get the token name, the token config, and it is creating a config file for us. Whatever we have seen before, it will create some set secrets and everything. And using this file, we are going to interact with the Kubernetes cluster. And if you observe clearly, we are also trying to get the target config token call from the developer namespace. We are getting a secret. Likewise, the reason why here I'm using a secret from the developer namespace is like, here I'm giving you like the straight and pretty straightforward answer, because after enumerating a bit inside the cluster, after going through different secrets inside the cluster as an attacker, and identified that this developer, someone like in the development namespace or in the developer namespace, there is a secret which has got a little bit high privileges. So I am saying that going forward, if I want to interact with the cluster, please use this secret for authentication and authorization, and talk to like the Kubernetes cluster using this secret and try to get some more info. So what I will do is I'll just quickly run this config file. So I'm in the temp folder, sh config.sh. Looks like it has done its job. Now let us see what it has generated for us. Cool, there we go. It has created a config file for us. This is the token that we'll be using to interact with the cluster. This is the certificate, and this is the IP, and we are using a name called research, which I have created for the workshop. So in order to use a kube config, instead of like the default kube config, we pass the file called flag kube config equal to config. And then we use the flag called, we pass like the rest of the commands, Cube Ctl get secrets -a. So for example, it says using this thing, they're using this developer secret. It says secret is forbidden. User, developers, or the service account, developer service account cannot list secrets. The user does not have the privileges or the permissions to access the secret. So, but being an attacker, the attacker won't stop there. And after enumerating a bit, he came across something called privilege escalation using misconfigured role or the role binding. So in Kubernetes, if you want to impersonate a user, or if you want to run commands as a different user, we use the flag called --yas. So after enumerating the cluster for a while, after doing a bit of research, the attacker came across a different kind of technique called impersonation. So from that, he identified that this service account called developer-sa has some privileges to impersonate as a group admin. Sometimes this is what we do in the real time. We may not give like the privileges to the users directly, but we give them, or we add them to a different group, and we let them, hey, probably like a normal user, you won't be able to do it. But at times, if you pass different flags, or if you impersonate a different user, you will have some high privileges. So after a while, the attacker has identified that this developer or someone, the user called developer-sa, has some privileges to impersonate the group called system masters. And then he tried to enumerate the stuff. Earlier, we didn't have the privileges to get the secrets, but when he is impersonating like the admin, the group system masters, he was able to get all the secrets. I'll also teach you like the technique during like the role bindings, how to stop these kind of impersonation attacks, what will let these impersonation of attacks happen. So here the attacker is successful. He was able to impersonate a group called system masters. Using a normal user, he could not get the secrets. It's forbidden, but after impersonating -as null as a group system masters, they were able to access all the secrets. So this is one technique where the attacker has initially gained access to the underlying cloud account or the underlying container or the pod, but he has limited privileges. But after enumerating a bit, he identified there is like an impersonation access to a particular service account, and then he is impersonating the rest of the commands using that service account. And this is something which I came across, or which we still come across in many of the penetration testings and the real-time assessments. So we were able to successfully access the secrets. And now we try to identify the list of pods that are running inside the cluster. And these are the pods that are running inside the cluster. And after enumerating a bit, the attacker came across, if you identify, we are still running inside a web application container that we gained access using remote code execution. And from this, we are actually interacting to the underlying cluster using an impersonation technique. So after going through all the commands and after identifying the pods, he came across something called Jenkins, which is like a build server. Usually, in the recent times in the organizations, these build tools are like the juicy targets. They're like the crown jewels for the attackers because they will have very high level of access to like your code base, or it could be to your to the infrastructure where they actually deploy the infrastructure or the code. Usually these build servers are given high privileges. If you come across 10 machines and if you see like a build server, the attacker will always target the build server first, because if he happens to gain access to the build server, it's a game over. So pretty much in the same scenario, in this scenario, the attacker still tries to attack this build server, and we see how we can attack Jenkins and gain access. So that is like the next scenario. So we identified all the servers that are running inside the cluster. There is a build server called Jenkins. So what I will try to do is I will execute some commands into that server. So you can copy and paste the command called so what I'm doing is it's pretty much the same thing which we have seen so far. I'm impersonating as a group system masters. So in the namespace called Jenkins, I'm executing some commands or executing into the container. Which one it is? It is like the Jenkins pod --bin/bash. There we go. So we are inside the Jenkins server. So far, using a web application bug, we gained access to one of the container or the underlying container. And from the underlying container, we try to identify some privilege escalation using impersonation technique. And using that impersonation technique, we identified a privileged pod or a build server called Jenkins. And we executed inside the Jenkins and we gained access to the Jenkins server. And from here, we see what else we can do. So basically, it's, as an attacker, I will pretty much do the same stuff. I will check for all the environment variables. There seems to be some juicy information, such as like secret. It says the password and the host name, the Jenkins port, the username. Just make a note of them, admin and the password Vasant. And we also have something called GOGS token. So we have some critical information, like there's some token. It could be like the build server and the username and the password. And if you ask me, hey, Vasant, will this really happen in the real time? Yes, these things still happen in the real time. Most of the companies, they still pass secrets as environment variables, or even if they inject during the runtime, you'll still be able to access this information. And this is something, the scenario which I have created based on my real experience. So when an attacker gains access to a build server, there are like different critical folders the attacker can always play with. So one such important folder is like the jobs folder, where different kinds of build jobs or unit testing, any kind of jobs that might happen on the build server. So I'm getting inside the jobs folder for the Jenkins. So exploring Jenkins is out of the scope of this workshop. So I have given like the straight commands. So I am inside the jobs folder. There seems to be one job created. Now what I'll do is I'll get inside that folder, cd docker file. The job could be like the company or the organization or the DevOps team is building some Docker files using the job or the Docker images. So here there seems to be config.xml, looks like some juicy information. I will try and explore that file config.xml. So it says, it reveals me like the internal Git repository. This is like the IP address or the path of the internal Git repository. Likewise, you can gather some other critical information from here. Let's make a note of it. So this is the IP address of the internal Git repository. And from here, we also have something called a token. So what I will do is using this token and using that IP address, I'll try to explore like the internal Git or internal code base repository. For that, the command is provided in the document. And these are very real-time scenarios that we still use while pen testing and infrastructure. And this is how we chain different attacks. So I'm passing like the token that is set as an environment variable. And this is the IP address that I'm trying to explore. And what I'm doing is I'm trying to get different repos that exist inside that environment, inside that internal repository. There we go. I got some information. So inside that repository, there seems to be having some repo which is creating Docker files or Docker images, some application repository, some developer, some environment repository from for infra. There is some backend repos, and there are some front-end repos. So this is how we can explore different repos, and you can always clone the repos and see some juicy information. From here, what I will do is I will just try to target the repo called Docker file, which the DevOps team might be using to build Docker images inside the infra. I'll get inside the temp folder. Usually in the organizations, most of the time, if you target like a master repo, there could be some restrictions in place, like not everybody can access those repos or not everybody can push directly to the master. You will have some workflows, or you need to trigger some things before you push something to the master branch. However, many companies still don't have enough restrictions for feature branches or the branches. Anybody can try, test different things on the feature branches. So as an attacker, instead of trying or attacking the master branch, I'm trying to gain access to the developer branch. So I'm cloning this one, git clone -b dev. Right, I have successfully cloned it. So I'm getting inside that repo Docker file. I'm inside the Docker file. Now let us see what the Docker file has. So here it says from HTTPD environment. So the team or the DevOps team, they are building some images from based on this image. So as an attacker, what I will do is I'll make some changes and I'll push these changes to the master or to the dev branch. And the way the workflows are designed these days in the organizations is every time you make some change to your repo, or you make some push some changes to the branch, it will immediately trigger the build servers, and it will do some assessments, and it will run all the things, all the steps, or all the build steps that we have configured in the build server. So we will see how we can take advantage of it, how we can attack the Jenkins server in this scenario. So here we'll have to play some bits and pieces of some Git. So what I'll do is we have seen what the Docker file has. So I'm going to remove this one, rm-rf Docker file. Cool. I'm going to replace this Docker file with a malicious Docker file that I have created. Just 1 second. So I have given the file in the documentation. You can just copy and paste it. Docker file. Cool. I have pulled the Docker file. Now let us see the contents of this Docker file which we have created, which we have pulled. Cool. So I'm saying from so and so, I'm saying like use this evil image. Being an attacker, I know what the evil image does. I have created this evil image in such a way that every time somebody spins up a container or uses this Docker image or this image inside their infra, it will immediately give some kind of shell to my infrastructure. So, and this is like the real time. There are like so many malicious containers or crypto miners that are posted in the Docker Hub and other places which have been recently deleted, and it's still happening most of the times. So I have replaced the old Docker file with some malicious Docker file. So some basic Git commands like git status. It says modify Docker file. So git add. Perfect. Git commit -m test. It says, please tell me who you are. Okay, let's. It is advising to run some commands. Copy this one. Cool. It's done. Git status. Git add. Git commit. It's like the file changes are happening. Now let us git push. So we have successfully pushed the changes to like the dev branch. And like we discussed before, every time you make some changes to a dev branch, there should be a pipeline which will be triggered and it will run all the steps that has been designed. So if you go back the very first page where we have did the setup, there is a build and deploy server for the dev environment. So just go and access this URL. Right, perfect. The username is admin and the password is Vasant. The username and the password, which we got it from here in the form of environment variables. So looks like a job has been run 30 seconds ago when we pushed it. If you click on Dockerfile, let us see what has happened. Cool, perfect. It has pulled, as per the Dockerfile, it has pulled the evil image from here. So, and these are the build steps that are by default defined in that organization. So we have just made some changes to the Dockerfile, and it has pulled the Docker image. It has successfully built the image, and it has successfully tagged as per that organization's naming schema, and it has successfully pushed it. So if you understand correctly, what we did is we using like the web application, we identified a remote code execution. Using that, we gained access to the underlying container, and in the underlying container, we gained access with limited privileges, but then we enumerated a bit and identified there is some impersonation techniques, impersonation bug, impersonation vulnerability. Taking advantage of that vulnerability, we try to get access to secrets and some pods. And from there, we identified a privileged pod, which is called Jenkins. We gained access to the Jenkins and we targeted one of the builds inside the Jenkins. We deleted and we created some malicious Docker file, and then we pushed the changes to the dev repo, and then it has immediately triggered the build, and it has built an image based on the vulnerable image that we have defined in the Docker file, and then it pushed it to the company's internal repository. So now what happens is, every time a DevOps or a developer, whenever they use this image inside their infrastructure, when they spin up a web application or a container based on this image, it will immediately give access to the attacker. That's what the attacker has defined in that evil Docker file. So let us see like how that can actually be exploited. So from here, I'll just quickly exit from the Docker machine and I'll do everything from the VM, the workstation, to make the lives easier, because here at times we are not use some commands like Control-C, Control-V or other stuff. So I'll be using like the VM, but pretty much once if the attacker gains access to like one of the containers, let us assume we are doing the same stuff. So what I'll do is I'll get back to the VM. So I will see all the pods that are running inside the cluster. So these are the pods that are running. So what I'll do is I will target this one called web app. So Cube Ctl, get PO, and this is running in the namespace called developers. Cube Ctl -n developers. I would like to get the manifestation file of this one. So that is the command which we have learned at the very early stages. We pass the flag -o YAML. So I will place this one into webapp.yaml. Cool. Now let us see cat webapp.yaml. Yep, the manifestation file has been generated. I will edit this file. So what I'll be doing is I will replace this image, which is the malicious image which we have created a few seconds ago. So, and everything is dynamic, guys. This is like happening in the real time. So this is the image. This is the thing which we have created and did it like just a few seconds ago. It says like 30th September 2021, 9:44 my time. So it's just happened like a few minutes ago, 4 minutes, 36 seconds ago. So we are going to use that image here. And I'll also pass some commands. Being an attacker, I know these are the flags that I have passed to that malicious image. So what I'll be doing is I'll be providing the attacker IP. I will just get a netcat listener, netcat-l 7777, and my IP address is 192.168.56.1. Just quickly check it. 192.168.56.1. To 168.56.1. Everything is good. Rest all is fine. So I'm going to save this one. So before deploying, I'll just check that one again, cat webapp.yaml. So we have replaced the image with the malicious image that we have created. We are passing some additional flags. So let us apply this one. For applying this deployment, the command is Cube Ctl apply-f webop.yaml. So the moment it is deployed, we should get a shell on this one. So this is what happens. So this is one example, but usually in the organization, the DevOps team will build. Oh, there is something wrong. Just 1 second, guys. I'm just checking it. Where is the error? The pod is run. I'm checking for the error. Just give me 1 second. Looks like I missed something. I know about YAML. Image. It's all good. Then I'll have to command cat. Looks like I missed something. Let us try this one. Otherwise, we will move on to the next scenario. We will tackle this in the last. Ctl apply nf.yaml. Still there is something wrong. So 6.1.7777. Or I'll try to do just one last technique. If this doesn't work, we will move on to the next one. We'll get PO, -n. Or that we are targeting is this one, the path, Cube Ctl. Sorry guys, just a small mistake. So here I generated a manifestation file for the pods, but I should be doing for the deployment because I'm making a change for the deployment. So cool. So Cube Ctl get deploy -a. So this is the deployment. So Cube Ctl get deploy -n. Developers get deploy -no YAML. Perfect. So what I will do is some evil.yaml cat evil.yaml. Perfect. Now I will edit this file. Perfect. So I am going to change this image. The image that we created, which is my tag assassin. Perfect. And we pass some args. Should work. Perfect. Control X. Yes. Cube Ctl apply fnf evil.yaml. Oh, there you go. This time it looks like it is successful. It has applied. Cube Ctl get PO-a. Looks like it is terminating the previous container, and we have like the new container coming up. So once the new container is up and running, hopefully we should have the shell on the netcat listener. Fingers crossed. Get PO-a. PO-a. So yeah, the container is up and running. Did we get the shell? Let us check for it. ID, there you go. We got the shell on the netcat listener. So this is what happens. So this is one example, but let us assume this is like a golden image, or this is like the base image that the teams build in their infrastructure. So every time any developer or any different teams, if they consume this base image, this vulnerable base image inside the infrastructure, and if they happen to deploy it, it will give like the remote access to the attacker anytime. Or this is one example. Or sometimes instead of building this kind of reverse shell, the attackers may also build some kind of crypto mining images, which will do crypto mining inside the infrastructure. It's not always about gaining access to the infrastructure or gaining access to the data, but given like the huge compute resources located in the cloud, crypto mining is one form of stuff that is happening these days. So, well, that successfully concludes this scenario. I would like to just reiterate what we have done so far. If you're using a web application remote code execution vulnerability, we gained access to one of the containers, and then we identified that it is running on the Kubernetes cluster using the environment variables. And then the attacker had very limited privileges to that container. And then after enumeration, he identified that the service account has impersonation privileges, and the attacker could impersonate as the group system admins. And using these privileges, he identified one crown jewel, which is like the build server called Jenkins. And then he executed inside the Jenkins. He gained access to the Jenkins, and then he targeted one of the builds that are running inside the Jenkins server. He made some changes to one of the build file. He removed a Docker file, and the attacker created a malicious Docker image. And it immediately triggered the pipeline. The pipeline has built the image and pushed the image, the vulnerable Docker image, to the Docker Hub. And what the attacker did is, like, just to show you an example, we changed one of the deployment and used the vulnerable image that we have created, and it immediately gave reverse shell or the access to the attacker. So it can also happen in different ways. Like I mentioned, the attacker can also create some crypto mining and crypto mining image. And anytime the devs or the DevOps use different images, it will start crypto mining in favor of the attacker. Well, that concludes this one. Now let's move on to the next scenario. This is again some interesting stuff, like using like the Docker socket mount. Like I said, the Kubernetes always needs some kind of container runtime that is up and running. So securing Kubernetes cluster or securing Docker runtime, the container runtime, is as important as securing the whole cluster. So let us see an example how an attacker, if they gains access to one of the pod, and if there is like a Docker socket mounted, and how the attacker will take advantage of it. So if you ask me, hey, Vasant, will this really happen in the real time? Will the Docker containers have like Docker socket mounted? Yes, because any of the monitoring tools, for example, it would be even like the security monitoring tools or log monitoring tools, will always have this Docker socket mounted onto the containers because they need access to the underlying host or to the underlying logs. Let's quickly look into that scenario, how we can abuse Docker socket mount. So I'll quickly get into the temp folder. We are good, guys. We are still on time. We are on track. Nothing to rush. So well, there should be, I will be creating and downloading a file which I have created for you. So just copy and paste that. If that doesn't work, just let me know. So just quickly apply this one. Cool. It says there is a pod called monitoring created. We try to attack this monitoring pod and see. So before that, I would like you to understand what it says. So what we are actually doing for this scenario is, like, we ourselves creating one test environment. We are deploying a pod called container called monitoring, and the base image is Alpine. However, what we are doing is we are mounting the Docker socket var/run folder of the host onto the container. So what this means, we will check it. So Cube Ctl get PO. Yep, the pod monitoring is up and running. Now let's quickly exit into this pod. Cube Ctl exec -id monitoring bash. Awesome, perfect. We are inside the pod. After enumerating the folders for a while, the attacker gets into the var/run folder, and there he identifies something called docker.socket. So after doing a bit of research, the attacker gets to know that when there is a Docker socket mounted onto a container, he identifies how to play with it and how to gain access to actually the underlying host. So let us see what happens. So you can use different ways to interact with this docker.socket. You can use curl, and you can use different other clients. But based on my experience, what I would simply do is I would add the Docker binary to make my life easier. It's just one simple command, apk add docker. Just remember that you are running inside a pod. You're not on the host. So we already have a Docker running on the host. However, now inside another container, we have installed the Docker binary again. So this is called Docker in Docker attack sometimes. So now using the Docker client that I have installed, I'll be issuing all the basic commands like Docker images. There you go. We are running inside a container. However, we are able to access with the underlying host and the underlying images. So from here, needless to say, what you can do, it's completely up to you. You can run different containers, you can grab reverse shells, you can delete images. And also one thing I would always do is like exfiltrate the images. For that, what I would do is you can just simply use the command called docker login using your personal credentials. And once you're login, you can just steal the images that in this corporate world. You can just steal them into your private account, upload them into your private account, and then pull them onto your local machine sometime later and do all the exfiltration stuff. So how to do it? Everything is given in the document. So you can go through it and you can try the stuff. These are the basic commands that we have learned before, like docker pull, docker inspect. You can play with all the stuff, and you have the commands exactly to do it in the documentation. So I will move on to like the next scenario, which is like, now we have seen attacking the master nodes. Now we will try to attack the worker nodes. So we will see how we can actually gain access to the worker nodes. I'll quickly exit out of this. I have created a file for you. Just download that one from the GitHub. You can use this URL. I will show you how to gain access to one of the worker nodes that are running inside the cluster. And these attacks may not be just be done by an attacker is always attacking from an external party, or it could always be some pen testers coming inside your infra, or even the developers who actually work with you like day in and day out. If by mistake, if you give some additional privileges, the developer can always abuse them. Developers are like techie savvies. They are way more technical and knowledgeable than the pen testers or the security professionals, because they are the one who actually build the stuff. So let us see what we have on the shell on node.sh. So basically, I'm just not doing nothing but creating a pod or a container. I'm using the command called an image called nsenter, and I'm leaving it to you like what nsenter means, what nsenter does. Just do a bit of research. But also I want you to understand that I'm passing a flag called privileged equal to true. So what I will do is first, let me identify the nodes that are running inside the nodes. Okay. For example, let us say I want to gain access to like the master node. So what I will do is node.sh. I'll just pass the node. And hopefully after some time, in a few seconds, we should get the shell on that one. Oh, cool. There we go. It says now when we run the command, we are running from the host, but now we are inside the control plane. We got the shell on one of the worker nodes. So this way, the devs who have like limited access, or even a pen testers who had like limited access, or even an attacker can always gain access to like the master node or any other nodes. So being an attacker, once I gain access to the master node, my target would be to exfiltrate and explore different sections, different folders. What's name? ID. So there will be some juicy folders on the master node. This is very good to keep a note. cd/etc/Kubernetes. And well, there you go. These are some juicy files for you to keep a note of it. Just keep exploring the stuff. admin.conf will give you huge information about you can have literally like you can take a copy of this config file, and like we have seen before, you can pass this config file and keep interacting with the cluster. Or there are some other stuff like Cubelet.config, manifest PKI. I'm leaving it to you to explore what this does, to what extent you can go using this information. I'll just quickly exit. So likewise, if you want to attack some other thing. For example, let us quickly see how we can gain access to this node. Bash. And bring up same command. In the next few seconds, I should have a shell on the other worker node. There we go. And this time we have like the shell on the worker node. So I leave it to you to export the rest of the stuff. So that's how you can actually gain access to like the worker nodes directly. And sometimes when you don't have access to like the master node or the API server, you can directly gain access to this one. So now the other important stuff is like the Xcd. We will see how to attack the Xcd client. This is like another critical thing for the Kubernetes cluster. So the setup has already been done for you. So if you give the command called Cube Ctl get PO, there is something called Xcd Client. Let us see. I have given some more commands how to interact with Xcd Client. We use a binary called Xcd Ctl, like Cube Ctl. We use Xcd Ctl to interact with the Xcd Client. So we pass the commands. There we go. Client, and this is the server. And now let us try to extract some keys from the Xcd Client. There you go. It is listing all the secrets that are available inside the Xcd. So again, pretty much what I do is like, as an attacker, I try to enumerate each and every secret and find out which secret has got like highest privileges. How I would do is you can just write a small bash script or a Python script to automate the stuff. So Cube system, for example, I want to explore one of the secrets in the Cube system. For example, this one, pod garbage collector. That way you will get the namespace. This is the token. So pretty much you can keep exploring like different secrets and enumerate and keep hunting for the token which has got like high privileges. So this is how you can attack or exploit the Xcd cluster. And there are like different other things that you can still do with the Xcd stuff, but I'm just leaving it to you to explore for the rest of the stuff. And there are like few other techniques that I have listed in the documentation. Please try those steps as well. And we have one important thing called how like the crypto mining attacks happen, but I would like to show like the crypto mining along with the monitoring stuff. That way we can also attack and also monitor at the same time. So I will leave that scenario to the last one. So, well, that pretty much covers the attacking scenario. And after this, we will be looking into like the defending stuff. We'll be looking into like the role-based access controls. We'll be looking into network policies. We will be looking into security context, admission controllers, and especially like the open policy agents, how to use them for defending these kind of attacks inside the cluster. So I just need to have a quick 5-minute break, and I'll catch up with you in exactly 5 minutes, and we will go ahead with the rest of the stuff. Cool. I'm back, guys. Let's start with the role-based called RBAC. So, well, RBAC is like a key security feature that protects your cluster by allowing you to control who can access specific API resources. Like we have seen before, the attacker was able to impersonate as a different user. And we also were able to access the cluster anonymously without any authentication and authorization. We will see how we can actually restrict these things using RBAC. So in Kubernetes, everything is a resource. The pods, nodes, services, service accounts, and all the rest. But these resources don't have ownership or permission attributes. Instead, there are like additional levels of abstraction called a role, which will define the rules that specify a set of resources and also a set of verbs, like the actions that one can take on those objects. And the role binding links a role to our identity. This might be a user, a group, or a service. This will actually complete the who part. So the roles and the role bindings apply to the namespace level. There are also cluster-wide equivalents called cluster roles and the cluster role bindings. As the name implies, cluster role and the cluster role bindings apply on the cluster level. So let us play with some basic stuff, the roles and role bindings. So cool. So I want you to all to get into this folder, which says like root code base, and then the files, and then we have a folder called RBAC. We'll be looking into some different stuff. And so let us start by, we have already seen this before. However, I would like to give you an example. Let us start by creating a namespace called RBAC example, in the namespace in which we will be trying all the stuff. And I will create a service account called dev user. Cube Ctl create service account in the namespace RBAC example called dev user. Likewise, I'll also create another service account, which is called admin user. Cool. Now I have a namespace called RBAC example and two users, a dev user and an admin user. And also we have seen in the document I have provided, if you want to impersonate, we use the command called -as. So I'm going to set some alias. So going forward, if I issue the command called Cube Ctl -admin, I am giving this command as a normal user, as an admin user. I'm setting up another alias RBAC example, which is like, see, if I run the command as Cube Ctl user, so I'm running the command -as system service account as a dev user. So going forward, if I issue something called Cube Ctl user, I'm running in the context of dev user. If I give Cube Ctl admin, I'm running as an admin user. So just to make the lives easier, to make the command short, I'm just setting up the alias. So let us try some quick examples. As an admin, Cube Ctl admin get PO, yes, because an admin have all the privileges and they can get everything. Now let us try the same stuff using a Cube Ctl as a normal user. Not because dev user cannot list. Dev user does not have enough privileges. Or let us see remove -a and just see like the pods. No, still the dev user doesn't have enough privileges. So what do we do? How do we provide privileges to a user, or how do we delete some privileges to a user? We will be looking into this stuff. So I have already created certain examples for you. Let us start with one called role. Let us look at a role. So let us see what this role has. So in the kind role, like I mentioned, we provide the resources, to what resources and what kind of actions a user can do. So this role says that anyone who has this role attached will be able to list and get secrets. So next one is role binding. So what this role binding says is, I have created a user called dev user in the namespace called RBAC-example and attach the role that we are going to create role get secrets above to this particular user. So when this is implemented, the dev user will be able to access secrets, list and get. Let us just quickly apply them and see. So Cube Ctl admin apply secrets. I initially applied the role. Now I'm applying the role binding. Now the user should be able to get, or the normal user should be able to access secrets. There we go. So Cube Ctl user gets secrets. Earlier he was not able to access anything, but now he's able to access the secrets because of the verbs list and get secrets. And if you observe one thing, we have restricted the privileges only to that namespace. The attacker can access the secrets in the namespace which we have created, RBAC-example. He won't be able to access secrets in any other namespace. Or for example, if you just pass the flag -a, there we go. Still, the attacker cannot, the dev user cannot access the secrets because he does not have privileges. So this is how, and this is where we actually use the role-based access controls to limit the access. This is pretty much like the users and the groups that we have in the Active Directory. This is at the namespace level. Now let's look at a quick example at the cluster level. So I have cluster role called get pods, which says we didn't define the namespace. Namespace is omitted since cluster roles are not namespaced. So to anyone to whom this role is attached, they'll be able to get, watch, and list at the pods across the cluster level. And we also see called cluster role binding. So I'm saying, hey, attach this role, whatever I'm going to create about a pod reader, to the user called dev-user who exists inside the namespace called rback-example. So let me quickly apply these things. I have created the role. Now I'm also creating the role binding. And now let us see, as a normal user, will he be able to access the pods or not? There we go. Initially, the normal user, the Cube Ctl normal user or the dev user couldn't access the pods, but now because of this role binding, he was able to access all the pods. So that's how we actually use the roles and role bindings to restrict the access. So previously, there was a scenario where there was like anonymous access to the cluster. So how did that happen? I have created a file called anonymous access. So in this scenario, if you look at, there is a role called cluster admin role, which comes with the Kubernetes cluster by default. Every time you spin up a Kubernetes cluster, you will have this role called cluster admin. And what I'm doing is I'm attaching this cluster admin role to a group called system anonymous, to a user called system anonymous. That is the reason why the attacker, initially we were able to hack or play with the Kubernetes cluster using anonymous access. So in order to see that stuff, Cube Ctl get role bindings. We are exploring the role bindings, -a. So these are the role bindings. Should be cluster role bindings. There is something called anonymous review access, which we have created. Let us see. Qctl get cluster role binding. There we go. So there is something that exists inside the cluster. It says like, hey, we are providing like cluster admin access to like the user system anonymous. That's the reason why it was able to. How we actually prevent from this one? Just keep enumerating and testing for privileged roles and eliminate these kind of rules. If you delete this role binding, you won't be able to anonymously access the cluster. I will leave it to you guys to test it. And I'll also tell you how to actually implement these changes and test it going forward. Please hold on. So that's pretty much here. We are covering like the roles and role bindings at the namespace level, at the cluster level, and we also have seen anonymous level. And I will also leave it to you guys how to avoid the impersonation stuff. Yeah. There is something called developer role binding. Let us see. Cube Ctl get role binding. Oh yeah, pretty much. So that is how you actually exploit or take advantage of the additional privileges. And these are the different ways you can actually restrict using like the role-based access control to the cluster. So let's quickly move on to like the network policy stuff. Well, basically the Kubernetes network policy lets administrators and the developers enforce which network is allowed using the roles. So Kubernetes by default allows pod-to-pod pods to communicate amongst themselves for simplicity. However, you can always use network security policies and some ingress rules to enforce a tiered architecture within the Kubernetes. Well, in simple terms, network security policy in Kubernetes are like simple example or simple replica of like the firewalls to let or block the traffic. So we will get into some examples of network policies. This is going to be an interesting example. So let us quickly look into one file and see what we actually define there. And before that, I will quickly delete Cube Ctl delete namespace rback-example, which I have created, and that will delete all the even the resources that we have created there. Cool. ls. So let us explore this manifestation file network demo app. This seems to be a pretty big file, but it's very easy if you understand. What I'm doing is I'm creating one deployment, which we have seen before. I'm creating a deployment, and the name of the deployment is like API deployment, and this is the image that I'm using. So this is one deployment, and I'm creating a service for this deployment. Service is something which will let us access the deployment that we are creating. So there's like another deployment called Nginx deployment, and I'm creating another service for it. So only two things that I would like you to note in this point is like the API deployment is accessible on the port 3333, and the Nginx deployment is accessible on the port 8080. So I will quickly apply both this file. So it says API deployment created, API service created, Nginx deployment created, Nginx service created. It may take just a minute or two to bring up these ports. Cube Ctl, FPL. It says container creating, Nginx container creating. It shouldn't take too long. The API deployment is running, and Nginx still creating. Cool. So in order to see the some flags, we can use pass the flags -- selector app equal to API. So API is running, and I'll pass one more thing. This time Nginx. Okay, we have like both the deployments that are up and running, Nginx and the API that we are doing. So we will just check for connection from the Nginx port to the outer world. Cube Ctl exec, and I'll choose one of the Nginx pod. Perfect. From Nginx, we are able to reach the external world. Now let's see if we can reach out to the API from the Nginx. Remember, we have created like the API service on port 3333. There we go. We are able to reach both API and the external from Nginx. Likewise, let us check also the connections from the API deployment. Ctl API deployment, and this is where we go. And I will try to see if the API deployment has access to the external world. Yep, even the API has access to the external world. Also, let us see if API can interact with the API itself. Perfect, there we go. So from Nginx deployment, we have access to the API and the outer world. Likewise, even from the API, we have access to Nginx and API and the outer world. Now let us play with some rules and see how we can actually restrict the traffic inside the Kubernetes cluster. So the first one I would play with is like the egress rule. I have created a file manifestation file for you. Let us see what this means. So here we are saying we apply this one egress to the match to the API port 3333 only to port 53 to the outer world. Let us see what this means. Cube Ctl apply -f egress. Network policy has been created. Now let's quickly take from Nginx pod. Let's try to exit the outer world. No, we can't access Google. Now let's try and access the Nginx service on the port 80. No, we can't access. However, let's try and access the API service on port 3333. There we go, we were able to access. So what we define in the rule is like, hey, if somebody is trying to access to any of the applications with the label called API on port 3333, let it access. And we are applying it to the Nginx. So that is the reason why from Nginx, we were able to access port or the API service on port 3333. Likewise, to make your lives more easier, let us see another quick example. So I'm saying that, hey, from the API or Nginx, like Api block to this one, we are trying to block some access. So this is like the IP address of the Google. Let me quickly check. Must have changed. Oh yeah, it has changed. So I'll quickly change this one. So I will apply this one, Cube Ctl apply -f. API equal to the ports. So now from the API pod, I'll try to exit and see if I have access to Google IP on port 80. No, I can't access on port 80. However, let me see an access on port 443. There we go, I have access. The reason is that's what we have defined in the file. Let it access only on port 443, but not any other port. That's how we can restrict the traffic inside the Kubernetes cluster based on the IP address range and the port number, or even on the labels. I have like few more examples provided to you in the PDF sheet. Just go and try them and play with how different network policies can be used to segregate or network the traffic. For example, in one of the scenarios, we gained access to the web application, and from the web application, we gained access to the Jenkins server. And that place, really, the web application doesn't need to have access to, doesn't need an access to like the build server or any other server. So that way we can use these network policies to segregate the traffic and stop certain attacks, pretty much like firewalls. Now, let us look at something called resource constraints, which is, again, a very important thing which will help us to stop some kind of DOS attacks or the resource consumption attacks. So when Kubernetes schedules a pod, it is important that the containers have enough resources to actually run. If you schedule a large application on a node with limited resources, it is possible for the node to run out of memory or CPU resources, or for things to stop working. It is also possible for applications to take up more resources than they should. This could be caused by a team spinning up more replicas than they actually need to artificially decrease the latency, to a bad configuration chain that causes a program to go out of the control and use 100% of the available CPU. So regardless of whether the issue is caused by a bad developer, a bad code, or some bad luck, what's important is that it has to be in the control. So that's where we actually use this resource constraint. And for that, we use something called request and limit. So request and limit are the mechanisms the Kubernetes uses to control resources such as like the CPU and the memory. We will look into that example. So let us look into CD memory limits. So let us start with a file called setLimitRange. I want you to explore and see what this is range. So we are creating a file called limit range, and we are setting some limits, like the maximum CPU is like 800 and the minimum is like 200N. So let us see what this means. Cube Ctl apply -f set limit range.yaml. Cool, the set limit range is created, and I have created another file called pod with CPU within the range, which means I'm creating a pod with the limits like 800M and 500M, which is as per the specs that we have defined. However, instead of testing it, let us test something which is pod CPU like less than or more than. That gives us like a better example. So by default, these are the limits that I have set, but I'm trying to deploy a pod with the CPU limits, which is higher than what I have defined. So what I'll do is Cube Ctl apply -f. It says forbidden error when creating pod with CPU more than limit.yaml, because maximum CPU usage per container is only 800M, but the limit is 1500M. This way, if there is some crypto mining attack happening inside the cluster, or if some of the containers or pods are utilizing like higher resources than what they actually require, this way we can actually stop. Likewise, if you want a container to be running always with some more than what is defined, for example, a pod with CPU more than limit that we have seen with less than limit. Now, Ctl apply -f less than limit, because this time we are trying to spin up a container with 100M, but the minimum limit that we have defined is like 200M. That's how we actually define like the memory limits, like higher limit and the lower limit, to ensure everything is under our control. The utilization and the consumption of the CPU or the memory is always under control. So likewise, I have a few more files and examples for you, like playing with the same stuff like we have seen, like the CPU limits. Likewise, you can also try for the memory limits and then spin up some containers with higher memory limits and lower memory limits. Now, what I will do is I will quickly delete whatever I have created so that it won't stop the rest of the workshop, or it might create it. Oh, perfect. Likewise, whatever stuff I have created in the network policies, I will try to create them so that it won't impact the rest of the workshop. We have seen like role-based access controls, and we have seen like resource constraints. Now, we'll be looking into the stuff called security context. This is another important piece. Like the security context defines like the privileges and the access control settings for a pod or a container. And they are actually defined as a part of the pod and container specification in the pod manifest and represent parameters of the container runtime. What it means is like there are different flags like privilege flag, privilege escalation flag, or run as a group, run as a non-root, run as a user. The different flags that you can actually pass to the manifestation file or to the deployment of the daemon set or the pod when you deploy it. And we will see like different flags for what it can actually be run. So for that, I would like to use an example called OPA. So for this one, you need to spin up like the OPA stuff in your machine. So what I want you all to do is just please run this command in your machines, launch OPA-stack workshop-dev. If you go to the section called admission controllers, and we have something called OPA under admission controllers, and there is this command, launch OPA-stack workshop-dev. And it will bring up like the OPA stack, and we'll be able to do the rest of this thing. So when it actually asks for any like a Slack or a webhook URL, you don't need to provide anything, just press enter, and it will spin up some containers. I'll just show you. So when you run this command, launch OPA-stack workshop-dev, it will bring up some containers, Cube Ctl get po-a. It will bring up these 4 containers called gatekeeper system, and it may take like a couple of minutes for you to see these things. So just issue this command, launch opa-stack workshop-dev. And once it is done, we can go ahead and practice with the stuff. So well, basically, like, what is this? What is an admission controller? Basically, it is a mechanism by which the request coming to the Kubernetes API server can be intercepted prior to getting stored in Xcd. They're like part of the Kubernetes API server. And using this admission controller, like the word implies controller, we can control the request coming to the Kubernetes cluster. Admission controller limit like request to create, delete, modify, or connect. They do not support like the read request though. So open policy OPA agent is like offers like it's like an open source service that can evaluate the inputs against the user defined policies. So how this works is like we use a language called Rego. The users can write some policies using the OPA custom language Rego. It's very simple syntax and small set of functions and operators. So once you write something in the Ego, it will be checked against the rule set. So here I want you all to remember 2 important terminology. One is constraint template and the constraint. The constraint template consists of both the logic that enforces the constraint and the schema for the constraint, which includes like the parameters that can be passed into a constraint. So what is a constraint? It is an object that says on which resources are these policies applicable. I'll show that to you in action. So this is like the architecture or how like the OPA works. It's like policy or a decision based. Some request comes in, we have like the policies that we have written. OPA validates the incoming service or the request against the policies. Everything is fine. It will let it to happen. Otherwise, it will reject it straight away. For example, these are the examples like which subnets the traffic is allowed to, or which cluster the workload must be deployed to, or from which registries you can actually download the images, or the capabilities or the flags that a container can run with. So all these can be defined in the OPA. Like I said, this is the command that you should be running it to have the OPA up and running. So let us see a demo. All right, quickly, can you all still see my screen or any issues? Just a quick hands up or some answer. Any issues, or you can still see my screen? Christian, can you still see my screen?
Yes, I can see your screen still.
Okay, perfect, cool. So there is a folder called OPA. Just let's get into like the OPA. Like different files that I have created for you to try, test, and play. So let us start with something called privileged containers. CD privileged containers. Samples. So here, let us look at like the constant template. It may look like Greek and Latin, but it's very straightforward. Here, what I'm trying to do is like we are trying to identify a flag called privileged under the security context. So if this flag is identified, we are saying like privileged container is not allowed. We want this to be blocked. We don't want the users or the devs or anyone to spin up like the privileged flag containers with the privileged flag inside the Kubernetes cluster. So let us apply this one, Cube Ctl apply -f, red.yaml, that has been applied. Now we need to apply the constraint. So how does the constraint look like? So we have already created a constraint template. Now we are saying, hey, please apply that template to pods. Apply FNF. It has been applied. Let us see some quick examples. Example underscore allowed. We are trying to run a container with a flag privileged equal to false, which should actually let us deploy it because we have written a rule to stop any containers that are being deployed with a flag privileged equal to true. So let us apply and see. It says privileged allowed created. Now likewise, let us apply, let us see what is cat example disallowed. So we are trying to spin up a container with a flag called privileged equal to true. There we go. So it says privileged container is not allowed because privileged flag equal to true exists. This is the reason why privileged container is not allowed. Nginx security context privileged equal to true. That's the reason why it could not deploy, because we have created a rule saying that don't let anyone to spin up a container or a pod or a daemon set, for example, a pod with the flag privileged equal to true enabled. This way we can stop most of the stuff. This is also called as compliance policy as a code or compliance as a code. In your organization, you might have sort of compliance or the policies saying that, hey, don't let users to spin up privileged containers or some flags with host path mount, some XYZ rules. So we define those policies or compliance rules in the form of a code. So this is one example. So I will quickly delete whatever I'm creating, so it won't impact the rest of the workshop. Cube Ctl delete -f. Example underscore allow.aml. Also deleting constant.aml. Now, let us look at a similar example where we have allow privilege escalation flag. So we don't want the containers or the pods to be spinning up or to be running with allow privilege escalation flag. What I will do is template.yaml. I'm simply saying that wherever we have like allow privilege escalation, just say or block it saying that privilege escalation container is not allowed. So let us apply this one. Now let us apply, let us look at the constraints. So we have created a constant template and now I'm applying it to the kind called pods. Ctl apply -f. So that has been applied. Let's look at a quick example of example disallowed, what we are trying to do. Cat, we are trying to spin up a container with a flag called allow privilege escalation true and see what happens. This checking against the policies that we have created. And ideally, you should not let us to spin up this container or this pod because we have the security context allow privilege escalation flag enabled true. There we go. It says denied the request. privilege escalation container is not allowed in Unix. So this is how we basically use OPA. In fact, the OPA can be applied anywhere to any extent. You can use the OPA even to your cloud infrastructure, to the cloud, to restrict certain things even in the cloud as well. Ctl -f .aml. So I have like created many other files for you, like testing, like letting or pulling the images only for the allowed repos or the capabilities or the host file system, HTTPS only. You can just try them. You have all the commands and everything is listed in the PDF. Just give a go. So no worries. So well, that concludes the OPA section. So we have seen different things under like the defending section. We have seen like covered like the role-based access controls, like role bindings, roles, cluster role bindings, cluster roles, and we have seen like the network policies, ingress and egress, and then we have seen constraints such as like memory limits and CPU limits, and we have seen like the OPA stack. And in the documentation, I have also provided like the pod security policy. A pod security policy is a cluster level resource that basically controls security sensitive aspects of the pod specification. It also defines a set of conditions that a pod must run within order to be accepted into the system. It's pretty much like OPA. However, it is going to be deprecated sometime soon, and I'm going to leave it to you guys to test it. So now let's move on to interesting stuff like the monitoring. I have like 2 or 3 minutes of monitoring theory part. So before we do monitoring, I want to run this command in your machines. So this is the command that you should be running. Launch monitoring-stack workshop-dev. It will spin up a few containers and it will bring up whatever we need for this workshop to go ahead. And please make a note of this IP address. This is like dynamic. It will depend on your machine, and it also, the username and password is dynamic for everyone. So please make a note of this username and password, which we will be using to log in into the screen. How this works is, just run the command launch monitoring-stack, the workshop-dev. Just copy and paste this command from the documentation. And if you have any issues, any errors with this step, just rerun the command. It should work. And please make a note of this IP address and the username and the password. And if you look at the pods, Cube Ctl get PO-A, we should see some new pods coming up. It says like container creating. It will create around 7 or 8 containers, which we'll be using for monitoring the stuff. So while this is happening, I would like to go ahead and discuss about some theory part. Shouldn't take more than 1 or 2 minutes. So you might be wondering, like, why are we even doing this after all the monitoring stuff? Because a Kubernetes cluster has multiple components and layers, and across each of them, we will find different failure points that we need to monitor. These are, we'll be looking at some typical use cases of monitoring today. Especially by monitoring the cluster, you can get an across-the-board view of overall platform health and capacity. Specific use cases could be like cluster resource usage, project and team chargeback, or node availability and health. Likewise, we will also look into like missing and the fail pods, the number of running pods or the secrets, and all kinds of stuff, like everything like application availability, application health and performance. And needless to say, like the monitoring plays a very vital role for any infrastructure, and Kubernetes is no exemption. So let's start. So I will try to access my monitoring stack on this URL. 2000. It will ask you for the username and password. I have just logged in. So In the document, I have given 2 JSON files that needs to be downloaded. Please make sure you download them, and we'll be using them in the workshop. Just copy and paste that URL in the browser. And if you have any issues with that URL, just copy them in a text pad, format it, and then use it in the command prompt. So what I will do is, once after you download those 2 JSON files, just click on this plus sign, and you need to click on import. So click on upload JSON file, and you should be downloading those 2 JSON files and load them. Kubernetes. So I'm just renaming it to Prometheus dashboard. And make sure you always search for this Prometheus data source like Prometheus. This is very important. And then click on import. And once the dashboard is imported, you should see some data being populated on the screen. It will give you heaps of information, such as like the nodes. This is like a demo cluster. That's the reason why you see a limited information, but in the real time, you have like the whole screen like glowing up like Christmas tree. So here it will, starting with, it is giving the information about like the nodes, workshop dev worker 1, dev worker 2. It is giving like the uptime since when it is up and running, and the memory that it has, and the CPU that is being utilized, the memory that is being utilized, the reads and writes, and heaps of information. Now let us import the other one, upload JSON file. Dashboard, import. This is another kind of dashboard which will give us like all the network related activities, the cluster memory usage. If you don't see any information immediately, just give it some time, because still the containers are coming up. Because the VM is a small VM, it might take some time, everything. However, it will slowly show up all the information in the next few minutes. So this way, this is how we can use the monitoring stuff. Now, let us dive into some more interesting stuff. Let us see how we can actually identify different kinds of attacks that are happening inside the cluster. So let us start with, let's click on this button called Explore. Explore, I want to just choose Loki. Loki will help us to get all the events or the audit logs that are happening, audit events that are happening inside the cluster, and Prometheus will give us all the resource usage. So let us start with Loki. And I know this is altogether a different thing, like writing these queries is not the scope of this workshop, but I have already written some queries for you and I have put them in the document. You can just try them. But just to test, like click on the log browser, and then let us choose the pod here, and then always choose, make sure you always choose the control plane pod, because control plane will have all the juicy information. Where is the control? Okay, this is the Kubernetes API server workshop dev control plane. And for the last 1 hour, show logs. There we go. Or maybe if you want to see for more, just click on like last 3 hours. Here we go. It will give all the audit logs that are happening inside the cluster. So for example, let us start and see if you want to identify any requests that are coming from the anonymous group or the anonymous user to the Kubernetes resources. Let us see how we can actually identify these things. One second, bringing up my notes. Yep, there we go. And let us give something, some pass the flag called equal to So if you look at, I'm passing the flag called anonymous to identify all the anonymous requests that are happening inside the cluster. It has brought up some, hey, these are the anonymous requests that are happening. So probably if you click it will show you like, oh, the time where the anonymous request has come from, which endpoint it is actually hitting. And along with it, these are the anonymous requests that are happening inside the cluster, out of which if you want to extract only the logs which are like successful, so you can pass like 200. It will further drill down everything. It will give you all the results which are like successful logs. It says, if you look at this one, it says user system anonymous. This is the source IP and the user agent, response status and the core 200 and the IP and the endpoint that they are hitting. So this is how you can actually, for example, let us do a quick stuff. Let us make some curl requests as an anonymous user. So curl-k, we are trying to access nodes, and we are trying to access pods, or we are trying to access secrets. One more time, secrets. As I'm creating some junk data for the example. So now let me reduce the time to the last 5 minutes. And if you look at, these are the logs that have been successful in the last 5 minutes. So if you look at, this is the stuff that we did just a few seconds ago. We are trying to hit the pods, or we are trying to hit the other stuff. Likewise, if you want to further drill down anonymous, and if you want to extract the data where anonymous user is trying to access the secrets, so this is how we filter the data. Secrets, last 5 minutes. There we go. It says an anonymous user is trying to access the verb secrets. So this way you can actually identify any anonymous and any anomalous behavior that is happening inside the cluster. Or for example, if you want to identify the total number of requests that are actually happening, it gives you like, hey, these many requests that have happened, around like 6 requests somebody's trying to access in the last 60 minutes. This is how you can actually define or write some additional stuff. So there is like heaps of other information that we can actually see. Now let's look at the Prometheus stuff. If you choose like the Prometheus here, and if you click on metrics, there are like heaps of metrics that comes by default with Prometheus. If you go to API server, it will give you all the information such as like a total number of API audits, event total. For example, if you look at these things, or audit level total, in-flight requests, encryption, or init events total, can get lots of information. Likewise, for authenticated, if you want to see authenticated user requests, these are the number of requests that have authenticated users done. There are like heaps of information that basically comes with this thing. Likewise, I have written some additional things in the document. For example, cube pod container info. It will give all the pods and the containers info running inside the cluster. It is the name, and this is the container where it is running. So for example, if you want to see the information of the nodes, cube node created, so it gives all the information about the nodes and the other stuff. If you want to see like the list of the secrets, Ctl secret info, it will give you a list of all the secrets that are inside the cluster. So this is how you can actually leverage the monitoring stuff. Monitoring is altogether a different animal. To what extent you can take it, it's up to you. There are like many other tutorials that are available to do like the monitoring stuff. We are actually running out of time. We have like 1 hour. We have like few more things to cover. But in the documentation, there are like heaps of other stuff for you to try and see. For example, if you want to see the containers that have been deleted or which has been seen in the last 60 seconds. So it will give you all the containers that have been deleted. Likewise, we have, if you want to identify the total number of namespaces, there are like different operations that you can do using like Prometheus and Grafana. This is just one example. Likewise, you can also use ELK stack. There are like many other things. So I leave it to you guys to try different other metrics inside the Kubernetes. And everything is defined in the documentation with different queries. You can try that stuff. So now let us look at like the build phase security. So build phase security is where we actually define or look into the security when during the build stage. For example, we have used OPA, that is considered as a build stage security when building or deploying a cluster. It is being validated against a set of rules. Likewise, when building or deploying the containers, you can also perform like Docker image scanning or container scanning. I'm sure most of you must have already done this, but still let us see a quick example. For that, I would like to use a tool called Anchor Gripe. /10. This is one of my favorite tools, which I use mostly for scanning. There are like many other tools that are available, but this is my favorite. So it has been installed. Right. I think it's populating the database for the very first time. That's why it's taking some time. Let's give a few minutes. There we go. It is up and running. Now let us list some Docker images that are running inside the machine. Yep, we have few images. Now use Scribe and let us test some image. For example, maybe this one, or I'll provide the image ID. Scribe the image ID. It is like setting up the DB, should be done in a few seconds. It is loading the image. So it is scanning the image. There you go. The scan has been completed, and it says like, hey, these many vulnerabilities exist inside this Docker image. So this is one example. Like, you can even imagine like the number of bugs that it has. Just one image has like almost in hundreds. So this is one of the reasons why like scanning a Docker image is always like plays a very vital role in securing. It says like 1,004 vulnerabilities in just one image. So I want you to try scanning some other images as well, like many other open source or scanning tools, but this is one of my favorites. Now we will look at some other interesting tools like Trivia and Clay. They have been provided in the documentation. We can scan them. Now we will look at the interesting aspect, which is like runtime security. So what is runtime security? It means like vetting all activities within the container application environment, from analysis of container and host activity to monitoring the protocols and the payloads of all the network connections. While creating an environment prevents the security risks from becoming a reality is paramount, monitoring containerized application at runtime is still essential. Runtime protection involves monitoring every cluster for all containerized applications running in each node. So for this, I will be using Sysdig Falco. So how you set it up is like pretty straightforward. So this is the only one command that you should be running in your machines. Launch runtime security stack workshop-dev. You can just copy the command as is from the documentation and run it. And when it actually asks for the Slack webhook URL, just press enter. If you have one, you may give it. Otherwise, just press enter. The reason why I have set it up Slack is like very straightforward. If something happens, if there is some anomaly, it will immediately alert you on Slack. And once you have everything up and running, like once you issue this command, it will bring up some containers in the background, which may take around 2 to 3 minutes based on your speed. So it is already set up in my machine. I will quickly walk you through this runtime stuff. Cool. So this is how it looks like runtime security. So far we have done so much stuff and everything has been recorded. And these are the events that have happened. For example, we try to do some remote code execution on the port 7777 and netcat remote code execution in the container, or launched privileged container, and these other stuff. For example, let's do some hands-on demo and see what happens. There is a file called event generator, which will basically generate some test data for us to inspect. So I will just apply, or maybe before applying, let us do it one hands-on. I will execute into one of the shell called Xcd Alpine bin bash. Cool, I'm inside the container ls. I'll just do some stuff like netcat or echo .txt. So whatever we have done so far should be reflecting in the runtime security stuff. So there we go. This is the stuff which I have done. Terminal shell in a container, and it will also give us the information about the name of the container, every stuff. This has happened just like few seconds ago. And we launched a command called netcat, launch suspicious network tool in the container. And then we try to create a file called test.txt echo. So this is like the runtime protection. Anytime there is an anomaly, it will immediately alert us. So the reason why I have used Slack is that because every time there is an anomaly, it will alert me on the Slack channel. So runtime security monitoring, so many alerts since the start of the workshop. But these are the recent ones. Recently, I have created a file called test.txt in the container like Alpine. So this is one. And the next one, like we try to exit and gain access to one of the containers. So this is like the runtime protection. Every time there is an anomaly, it immediately alerts us. So in setting up, this lab hasn't been easy, like monitoring and everything, like the runtime protection. I have made your lives easier. You just need to like run one command to set up this infrastructure and then just try and practice it. So likewise, you can try different stuff. And I also have something called event generator, which will generate some test events. Cube Ctl apply -f event generator.yaml. It has been created. Cube Ctl get po -a event generator. Oh, that should be job. Job -a cool. Event generated job has been completed. It must have generated some alerts. So these are some alerts that it has created. Dashboard. So that's how you can actually use like the runtime protection. Runtime protection plays a very vital role. Well, one thing I would like to show, which I didn't show in the beginning of the workshop, is like the crypto mining attack. I'll just do it. You can do it in your machine, or there's a possibility that it might crash. However, let me try in my machine, or you can do it along with me. So in the attack scenarios, we have something called crypto mining attack. Just follow those steps. We will be deploying one container. Let's get into temp folder and download this file. At the same time, we will be monitoring this using like the OPA monitoring stack. The file has been downloaded. Let us see what this does. Crypto.yaml. I'm running like an image called crypto miner, and it is doing something else. It is doing some kind of mining, and it is also has like the memory limits and CPU limits set appropriately so that it won't alert anything. Also, the memory request has been set so that it won't consume too much. So Cube Ctl apply -f crypto.yaml. The pod miner is created. So while this is happening, what I would do is I will get into my OPA stack. Sorry, I'll get into my monitoring stack, which is running on port 2000, which we have seen before. So let us get into Kubernetes dashboard. Just keep observing this stuff. We have just launched the miner, and let us see how the behavior changes here. Let us observe like the used section. And also while this is happening, let's see some interesting stuff like the metrics. For example, let us choose Loki, and let us see what this pod miner is actually doing, like log under the pods. Interesting. Pod miner created. Ctl po-a. Oh, the pod miner is still being created. That's why it is not showing up. Let's give us a few more seconds. Now the pod miner is up and running. Loki. log browser pods, or let us search for the minor pod. Cool. Show logs. So this is how also you can use the monitoring stuff to see actually what's happening inside a pod or a container. Probably I would not want to discuss this stuff. This is out of the scope, like what's happening as a part of the crypto mining, but in the monitoring, using the monitoring stuff, you can monitor like what's happening with the containers. And also, if you go back to like the dashboards, using one of the dashboards which we have seen before, initially everything was like green, and now seems to be, if you look at the CPU utilization has increased to 96, 98, and the partition memory utilization has been increased. I'll quickly delete this one, otherwise it might crash my machine. Cube Ctl apply, Cube Ctl delete. So this is how you can leverage monitoring stuff to identify any crypto mining attacks that are happening inside the cluster. You can directly see what's happening with the pods using the logs, and also you can use like utilization resources. So within just fraction of seconds, the utilization has spiked up to like 96%. If you leave it for a while, the machine might crash, or the utilization might be like very high, not letting the other resources to have enough resources. Machine has become already slow. But in the next 1 or 2 minutes, again, everything should be like back to green and back to normal. So this is how like the crypto mining attacks happen, and this is how we can actually leverage the monitoring stuff to identify and defend against the crypto mining attacks. We can also write some kind of Slack channels and alerting, and possibly we can also use like the runtime protection to identify these kind of attacks. If you go through these logs, you will find somewhere about the crypto mining stuff. So it's been already 1 minute since I deployed. Now, if you look at the utilization is coming down slowly back to orange, and then it will be like back to normal because I have deleted my crypto mining stuff. Well, that pretty much concludes like the runtime security. I just want to cover like the last piece, which are like some useful tools which we use in the real time. And I would like to start with K9s. Basically, K9s provides a terminal or the UI to interact with your Kubernetes cluster. It's a very handy tool. And the aim of this project is to make it easier to navigate, observe, and manage your applications in the wild. And K9s continually watches Kubernetes for changes and offers like subsequent commands to interact with your observed resources. So it has already been set up in your VMs. You can just follow the commands that I have provided in your machine in the PDF. So in order to bring up K9s, the command is like just K9s. That's it. And it will bring a beautiful CLI. This is a CLI, though it looks like a UI. So this is my pod, my cluster information. If I choose, it will provide me all the information such as like different namespaces, pods, and everything. So you just need to press escape and shift semicolon to run the commands. For example, if I want to see all the namespaces, just namespace, it will list all the namespaces that are running inside the cluster. For example, if I want to see all the information of the pods, likewise secrets, or deployments, it will give me all the information about the deployments. For example, if you want to get shell access into one of the pods, choose the pod that you want. And here it defines if you want like the shell, just press S. So I'm pressing S, and it will give me a shell inside that pod. That's so handy. So what else you can do? It will, if you want to see like the deployment, just press Y. It will give you like the complete manifestation file of those deployments. And there are like many other things that you can try and play with this stuff. So let me quickly go to the next one. I would like to show you the tool called Cube Striker, which I have been working and building. last few months. You can spin up the Cube Striker with just one command. Well, I would like to show you the documentation side of Cube Striker. It is cubestriker.io. There is a documentation. Click on docs at a glance. It will give you like the different editions. It has like two types of versions. One is command line interface. The other one is web application. It will has like the current capabilities it can do and how you can actually spin up a container, how you can perform different kind of scans. Everything is listed in the documentation. Just give it a go, give it a try. And it also exists on GitHub. This is the page. Just type GitHub Cube Striker. And this is the link for the tool. Just start it because I'm going to release a good version with some major updates for the Black Hat Europe, which is happening next month. Just keep an eye on this one and share the word with your community and with everyone. And I'm always looking for contributors. If you're like keen to contribute like part of this project, just please let me know and I'm more than happy to welcome. So this is the link, GitHub and Cube Striker. And this is the documentation, cubestriker.io. And let us see like the Cube Striker in action, at least the command line form. So we are inside the container, Python-m, Cube Striker. We'll gear up the Cube Striker. Oh, interesting. Just a small spelling mistake. Python-m Cube Striker. There you go. The Cube Striker is up and running. So it will accept three types of inputs: the URL or the IP address or the config file or like the range of IP addresses, which can have like the list of master IPs and the worker nodes. So in this scenario, let me scan using a URL or an IP. So my IP address, this is the IP address or the URL, I just provide it. So once if you provide the URL and the IP, it will start enumerating like for different services. It will start for secure port, insecure port, all the things that we have covered during the workshop. And once it is identified, it says, hey, these are the endpoints that have been identified. In this cluster, we have Cube Server secure endpoint identified, read-write service endpoint identified, Xcd Client, Xcd Server, Cube Proxy, and there is like Open Port 22, which is an SSH that has been identified. And it will give you two options to perform the scans, whether it is like an authenticated scan or an unauthenticated scan, which is like a black box testing versus like a white box testing. So in this scenario, let us, because I have an anonymous access enabled, I'll go and scan like an authenticated scan. And it supports like different clusters running on-prem, or it could be like a cluster running in Azure, or it could be a cluster running in EKS, or it could be a cluster running in Google Cloud. It will support all kinds of clusters. And in order to provide a token or an authenticated scan, these are the commands that you should be using to grab the token. So in this scenario, because there is an anonymous access enabled, I'll just press enter without providing any token. And it says authentication successful because anonymous access is enabled, and will give us an information option like perform all checks or perform individual checks. I'll go with perform all checks. It will start scanning for IAM misconfigurations like admin roles, read-only admin roles, destructive roles, whatever we have seen, like impersonation, all these things are identified using this tool. Then it will scan for misconfigured containers such as like privileged containers, liveness probe, readiness probe, these things. And then it will check for pod security policies, network policies, Cubelet read-write service. If you run the scanner in a real time on a running cluster, it will give like heaps of vulnerabilities or misconfiguration inside the cluster. And once the scan is done, it will also give you an option called execute commands on the containers. You can play or interact with the containers during the pen test. If you come across with any of like anonymous access or any other stuff, you can actually execute the commands. So these are the pods that are available. I choose one of the pods. It will list all the containers that are running inside the pod, and we choose one of the container. It will ask me to enter the command. I press ls. So command execution successful. So that way you can do it. And once it is done, click on exit. It says scan completed and the results generated with the target file name. So the target file name, this is the target. What is the target that we have input? 192.168.99.101. And we have file called 99.101. Let us see the output. It gives like a very elaborate output This is the beauty of this tool. It gives, like, for example, read-only admin roles. It says like who has what kind of role. It is a cluster admin role. And this particular service account called generic garbage collector has read admin privileges in the namespace Cube system. It will give very useful information like who have access, what can do. And it will check for privileged roles, pod security policies. It will check for containers with various misconfigurations like CPU limits, readiness probe, memory limits, priority class name secrets, mounted Docker socket, etc. Just give a go and try it on different clusters, and you will make the best use of it. Well, that pretty much covers the Cube Striker. And there are a few other tools that I have listed inside the documentation, like Popeye and other stuff. So Popeye is pretty straightforward to install. It is again built by the same team who has built the K9s. So just run Popeye. Probably it's not set up in my machine, but yeah, you can try it and give it a go. And needless to say, Cubelet is another tool that you can try. I have given the commands and everything in the documentation. Cubebench is another tool that you can try and test. Cool, we are on time exactly, and I think that we have covered pretty much everything. Fortunately, all the attack scenarios have worked. We have seen different kinds of defending scenarios, and we have covered monitoring stuff. And if you feel that this is not enough, there is like heaps of stuff in the documentation. Just give a go and practice the stuff and try like the runtime security and all other things. Well, that pretty much concludes the session for today. We still have like 20 minutes left. If you have any questions, I'm like more than happy to take them. And you can always reach out to me on LinkedIn if you need more information. And one thing I would like to share with you all is at the very beginning, we have set up this stuff. So just go to like the build server 8080. Now, initially at the very beginning, I told you like whether you want to click on proceed and abort. So now if you click on proceed, it will spin up another Kubernetes cluster along with the cluster that we have tried. So if you want to fix the bugs and test it, you will have like 2 more clusters. So I will leave it to you how to actually interact with the second cluster. Now we will have 2 clusters running in the same VM. But so far we have been interacting with 1 cluster, and I will leave it to you to figure out how to interact with the second cluster. You need to play with the Cube config files that we have discussed in the document. The solution is inside the document. I leave it to you to test it and go ahead. And it is like an inception. Everything is built using the containers. For example, Docker PS, I'm using something called kind. So on a host, everything is spin up using containers, and inside the containers we have like the Kubernetes containers, Kubernetes clusters running, and inside the Kubernetes clusters again we have like multiple containers and the build tools, build servers running, and along with the web applications. Some decent amount in time has been spent on setting up this lab to teach people and everything. Hope you liked it and appreciate it. If you need like more information, if you would like to learn more stuff, like I said, I had to make some changes to the content to fit in the 3.5 to 4 hours. But if you like to learn more, I have like more modules. Just reach out to me and I can help you with some more labs to just practice and test. Well, that pretty much concludes the session. If you have any questions, I'm like more than happy to take them.
Thank you very much, Vasant. That was very good, very professional, and I think quite clear, and a lot of thoughts for everyone. So there is a question on the Q&A, and I also saw that Adrian Rico, you had your hand raised, but you lowered that. Do you want to ask a question live? I can give you, I can allow you to talk if you want to. So you raise your hand again. I can allow that.
Does it works in a bare metal air gapped cluster? Adrian, I didn't do much research on the air gapped cluster, but I can definitely get back to you in some time. Oh yeah, absolutely. KubeStriker works on it. KubeStriker just needs access to your URL or the IP address, and it does all the scanning on it. Like I said, you can perform two types of scanning, like authenticated scan and unauthenticated scan. And you can also use it in the CI/CD pipeline even before you deploy the cluster to the production. If you have it up and running in the dev, you can invoke this container in the form of CI/CD, and it's very user-friendly, CI/CD friendly. You don't need to pass any commands in between. Just one single command will scan your whole cluster. You can build a different step in your pipeline, and you can scan the whole cluster. And just refer to the documentation like kubestriker.io. It has like heaps of information. And just keep an eye on it. I have like new version releasing in the next month, which will have like a better UI with more features, with continuous runtime monitoring and protection, with container scanning, everything. And it's going to be like an open source.
Cool, thank you, Joe. I don't know if you'd like to follow up with something. You can now talk on Zoom if you want to.
Well, I don't have anything much to discuss, but if anybody has any questions, I'm more than happy to take them. Or else I'm available on Slack. Just ping me there, or feel free to reach me on my LinkedIn. I'm available at. So this is my LinkedIn name, Vasant Chinnipilli. You can just send me a request over here, and you can always anytime reach out to me.
All right, thank you very much. And I guess you also can drop questions later on Slack or something, or contact Vasant on Twitter or whatever about the KubeStriker or the workshop in general. Remember also that he put all the information on the PDF, so you can like complete all the steps again. So yeah, you have a ton of information to play with. Thank you very much, Vasant, for your time. I know it's very late now in Australia.
Thanks so much for organizing this, Christian. It's very good, and thank you very much for giving me the opportunity. Looking forward to work with you again soon.